Hello everyone, my name is Sierra Sabalas, and today we are going to talk about fasting. So for those of you that are experienced fasters, you may already know what fasting is, but for others who may not be so familiar, fasting is the process from abstaining from food, water, or sometimes both, for an extended period of time. This practice of healing has been used throughout history, and as we develop more information through modern science, we are now learning more about both the inner and outer benefits that fasting can bring. Through this presentation, we will be learning about the 4 different types of fast, how fasting can affect the body, the physiological processes that happen in the body during fasting, how fasting could possibly treat and heal neurological diseases, how animals, such as the polar bear, use fasting when they are undergoing months of food deprivation, how the herpes virus could be destroyed through fasting, especially in cancer patients, how fasting could treat the coronavirus, and then we will finally be discussing the famous author Upton Sinclair and how he used fasting to treat many of his ailments. By the end of this presentation, I hope that you learned more about fasting and how this could create a better and healthier you. So first we're going to be talking about the different types of fast a person can do. So I found this under the article, Can Fasting Help with the Flu or Common Cold? And this was written by Media NV. This was found under MuslimVillage.com, and MuslimVillage.com is basically a website where you can learn about the Islamic religion and basically the Muslim lifestyle. And so, according to this website, there are 4 different types of fast a person can do. There is an absolute fast, a water fast, a juice fast, and an intermittent fast. And so, I'm assuming that for maybe some of you who have done a fast before, you may have tried 4 of these, but for some of you that never fasted before, an absolute fast is basically the way it sounds. It's where you abstain from food and water for an extended period of time. So that means that not only can you not have any food, you can't have any water, and not only can you not drink water, you basically can't go swimming in water, you can't take a shower, and basically you can't get near anything that has water in it. However, some people might think that an absolute fast may be a little bit too intense for them, so that's why some people may choose a water fast instead. And so with a water fast, all this involves is that you're drinking water only and you're abstaining from food. And then we have a juice fast, which is where you drink only fruit or vegetable juices. And then we have intermittent fasting. So intermittent fasting is though with intermittent fasting, you're basically changing your eating windows. So you're still sticking to the conventional breakfast, lunch, and dinner, but you're choosing when you want to eat it. Like for example, you're not really doing the whole order with your eating schedule. Like you're not doing the whole breakfast, lunch, and dinner in order, but instead you may decide to do lunch, for example, and then you may decide to do dinner, and then you may decide to skip out on breakfast entirely, and so no breakfast. But then it can go the other way around. You could choose to have breakfast, and you choose to have dinner, but you just won't have any lunch. And so basically, this is all intermittent fasting is that you're sticking with the conventional eating schedule that's always been around. But the thing about it is that you're just not doing it in order. You're choosing you're basically choosing your eating windows and when you want to eat it, basically. So now we're going to talk about fasting, the physiological changes in the body. So this information came from an article written in 2017 by Dr. Edward Group, who's part of an organization called Global Health, and this is under the article called "The Stages of Fasting: What Happens to Your Body When You Fast." And so basically, he just talks about the stages the body goes through when you're fasting. And so during stage 1, this is probably going to last for about 12 to 48 hours after your last meal. And so during this stage, your body transitions into fasting mode, and in fasting mode, hunger pains begin begin to happen after you're skipping your regular meal routine. This also causes a negative mood or irritability for most fasters. So when eating, your body breaks down glucose to get energy it needs for functioning. However, when you're fasting, your body produces sugar for energy, known as gluconeogenesis. So the thing about fasting is that you're not gonna. I mean, you're still gonna have a little bit of glucose left, but the thing is that your body's gonna be more than likely storing that glucose, because glucose is like a sugar, with sugar, yes, your body needs it, like natural sugar, like glucose. But the thing is that it can't have it while fasting, and so that's why the body produces sugar for energy, known as gluconeogenesis. So, what is gluconeogenesis? Well, that's where the liver converts non-carbohydrate materials like lactate, amino acids, and fats into glucose. And so basically what your body is doing is that it's not using glucose anymore, but it's actually storing glucose. It's actually storing glucose for itself. And so that's when the gluconeogenesis process happens, because again, this is where the liver converts non-carbohydrate materials like lactate, amino acids, and fats into glucose. So that way your body can have, like a bigger energy supply of it for when you stop your fast. So also during your fast, your basal metabolic rate, or BMR, will become more efficient. And so, because it's becoming more efficient, you're gonna use less energy. And so that's why when you start your fast, that's when you start fasting at first, you're gonna get a little bit tired, because your basal metabolic rate is resting, and so it's not gonna use as much energy as it did before starting to fast. However, when you fast for long periods of time, contrary to popular belief that you'll lose more energy, you're actually going to be doing the opposite. You're actually going to gain more energy, because again, you're giving your basal metabolic rate a chance to rest, and because it's going to be resting, it's actually going to come back recharged, and so you're actually going to be giving yourself more energy. And so now that we've talked about this, let's talk about the benefits for mental strength and heart health. What are the benefits of fasting for mental strength and heart health? Well, number one will be that it increases willpower. So basically, when you're eating, your body's really focused on digesting, and so when it's focused on digesting, that means it's not able to focus on other body parts. So, and we're going to talk about this later on. But when you're fasting, then your body is taking a break from basically from digesting, then it's going to start focusing more on the other organs. And so remember when we talked about gluconeogenesis? Well, gluconeogenesis, not only is it helping turn all those elements into glucose, but it can also help with turning those elements into ketones. And so ketones during a fast are basically where it can help give you extra energy. And it can help give your brain extra energy also, because if there are ketones in your brain, then that means that you're going to have less brain fog. And if you're going to have when you have less brain fog, that means you're going to have more willpower. And so not only are you going to have willpower, but it's also going to help with cleansing, and it has heart health benefits as well. And so also your BMR lowers, which we talked about earlier, and because your BMR lowers, that means that you're going to get more energy. Also, the fat in the blood starts to disappear, and soon it's going to metabolize itself for energy. So basically, if you have fat in your blood, or in your veins, or in your vessels, I should say, then when you fast, your body's actually gonna make it disappear. So what it's gonna do is that's gonna eat it up, and then it's gonna help metabolize it, so that way you can get more energy. It's also going to promote healthy heart, because again, just let's say for example let's look at the example of a heart attack. And so heart attacks are usually caused by a plaque, and a plaque or built up fat in the arteries of the heart. And so basically, when you're fasting, the fat's actually again going to disappear. So your body's going to eat it up, and then when it eats it up, then it's going to actually metabolize it for energy. And so when that happens, you're actually going to be you may actually be at a reduced risk for heart disease. And so it can also improve cholesterol levels by boosting HDL levels. And so with HDL levels are basically how much good cholesterol you have in you. So when you're fasting, you're actually going to be improving those good cholesterol levels, and there's going to be more of an increase in them. So now we're going to move on to stage 2, day 3 of 7. So now we're on stage 2, day 3 of 7 of our fast, and at this point, it's going to last until day 7. And during this time, you're going to experience changes in physical appearance and feelings will start to happen. So a physical appearance, let's say, for example, that like you have really bad acne. And so when you start a fast, you're going to notice that some of that acne is disappearing. And also you may have less acne, and so you may get a better complexion. And so also feelings. So by feelings, this means that, and so when I first studied this, I was like going, okay, so what do they mean by feelings? And it turns out that when we are fasting, we're actually getting more serotonin in us. And so for those of you that don't know what serotonin is referred to as a happiness hormone. And so when our body's not focusing on digesting, it's actually focusing on other parts, including hormone release. And so when it's focusing more on hormone release, it's more likely that we're going to have increased levels of serotonin. And when that happens, we're going to have more of a happier and calmer mood. And so also at this stage, ketosis begins. And we talked about this earlier. Ketosis is just where your body makes ketones, but you're probably wondering, how does it make ketones? Well, remember when I told you that like the body can't live on glucose? Well, what happens is that since it can't live on glucose, it starts to live on fat as its primary source. And so, since it's living on fat, you may experience hunger and fatigue during this stage. Since again, your body's used to living on glucose, and as we all know, glucose is just sugar, natural sugar, and so your body, in a way, has to be taken off of that for a little bit. And so, in a way, it's kind of trying to adjust. And so, during this adjustment stage, or ketosis, glucose is more limited. And so what happens is that since glucose is more limited, your body's going to use fat storage for energy, and that requires. And as a result, it's going to break down fat into glycerol and fatty acids. And from there, the liver is going to synthesize ketones using glycerol. So by synthesize, it's going to make ketones using the glycerol. And then the glycerol is going to be broken down by the liver. And when it's broken down by the liver, that means you're going to get additional glucose. So in a way, with ketosis, you're going to be getting both ketones and glucose. Because remember, with the fast, your body's going to be basically simplifying those fatty molecules and turning them into ketones, while in the liver, the ketones are going to glycerol is going to be helping turn that glucose into ketones, and then the glycerol is going to be broken down by the liver to get additional glucose. And so from there, the ketones will be used by the brain as glucose, and it will become less available. So the other benefits of fasting would be weight loss and cleansing. So ketosis targets fat stores that remain untouched even when living a healthy lifestyle. So even if you're living a healthy lifestyle and you're staying away from junk food, period, your body's still not able to access those fat stores because your body's still eating. And when it's eating, you're not able to focus on its other tasks. And so what happens is that when you start fasting, your body uses those fat stores to store toxic metals and other toxins, so they can wreak havoc on the system. Also, during ketosis, toxic metals and toxins are expelled from the body as fat reserves get used up. And so basically you're getting two benefits here. Your fat reserves are getting used up, and then the toxins are getting out of your body. And so this cleansing effect may temporarily alter some people's complexion or cause other signs of a healing crisis. And so remember when I told you about like that if you had really bad acne and you started to fast and you started to notice your acne going away a little bit? Well, that's because your body's getting rid of all those toxins. And so when it's getting rid of those toxins, that basically means that means that your body's cleaning itself, and it's also cleaning your face also. And by healing crisis, so the thing about this is that a healing crisis is not bad, despite the word. It's not bad at all, because the healing crisis is actually good. Because the reason why it's called a healing crisis is because when you're fasting, your body is no longer is no longer eating. And so when it's no longer eating and getting all that nutrients, it's kind of start freaking out on the inside, because it's kind of sort of like it's wondering what it should do, and it's kind of sort of like it doesn't really know what it should do at this point. But then as it gets used to it, your body kind of sort of figures out what's going on. And so that's why they call it a healing crisis, because it may, like on the outside, it may not be a healing crisis to you, but to your body it's a healing crisis, because mainly it's a crisis to your body because it's in this new environment and it's trying to navigate what it should do with itself, basically. So now we're on stage 3, and during stage 3, this includes improvements in mood and mental clarity between days 8 and 15. So this is also when your fasting high begins. And so this happens when the body fully adjusts to fasting, because remember when we talked about that healing crisis? Well, with the healing crisis, your body is kind of sort of stressing out a little bit because it doesn't know why it's getting deprived of food, or why it's getting deprived of water, or why it's getting deprived of both. And so it's kind of sort of freaking out. But once it hits the fasting high on stage 3, that's when it starts to fully adjust and basically says to itself, "Okay, you know what? I think I can get used to this." And so the improvements during the stage will include an elevated mood, increased energy levels, and a type of clear-mindedness. Also, this is when healing mode begins. And so what happens is that the digestive system takes a break from the common stressors and toxins it endures on a daily basis. And so during this phase, the body also has fewer free radicals and oxidative stress decreases. And so this causes mild stress, but it's comparable to stress caused by exercise, and it makes you stronger and your immune system more resilient. So during your fast, again, it's going to be a little bit stressful on your body. You may have some symptoms, but then once you get through this part, it's going to make you stronger, and not only you stronger, but it's going to make your immune system more resilient and stronger as well. So the benefits to this also is healthy aging. So by limiting free radicals and oxidative stress, this encourages healthy aging, and it positions yourself for fewer health complications. So now we're on stage 4, day 16 and beyond. So at this point, you're not going to experience any major shifts, and the balance starts to set in. So your body starts to recognize this balance of like when it should eat and when it shouldn't eat. And so basically what fasting is all about really is about kind of sort of like reprogramming your body to balance itself out a little bit more, because you don't want it to like be eating all the time, but at the same time you don't want to stop eating at all. Just like you gotta like set in a balance. Also, there's an extension of the completion of healing and the cleaning processes. And also, if you do decide to do a long fast, then you're going to have the opportunity for the body to heal and cleanse itself. So the benefits of this stage is that you're going to be focusing more on your personal goals and growth. So during the final stages of fasting, this will include the accomplishment of personal health goals. So let's say, for example, that you've been wanting to exercise more, but you never got the chance to. Well, when you're fasting again, you no longer have that brain fog, so you don't really feel you don't feel like you feel basically more motivated, and so that's what it means is that like you're gonna be more of a likelihood that when you do fast, then you're gonna be more there's actually gonna be more motivation in you to do the stuff that you wanted to do. Now we're on stage 5, which is breaking the fast. And so this happens sooner or later depending on your goals. So depending on if you're doing a short fast or a long fast, well, the whole breaking the fast process is going to depend on how long you decide to do your fast. And so depending on the length of it, you may have to ease your way into eating solid foods again. So fruit juices, cooked vegetables, and broths will help us stimulate the body to eating internal mechanisms again. So the key is that you don't want to start you want to start slowly. So you want to ease your way into eating solid foods. And so the best thing to do, like it said here, is to start by having softer foods. Like I said before, fruit juices and broths, and for the cooked vegetables, like some people say that's better to like have them raw because they have more nutrients for you. So just like everybody's opinion is going to be different on that. So the benefits will be starting something new. So before you start your fast, you have to make plans before you start it. So the best thing to do is to write down what you're doing to get out of it and what you want to accomplish. And so if done correctly, you can end the fast at a good time, and you can also begin a healthier diet and lifestyle. So for additional fasting tips, you may experience bowel movements and bad breath since they're common during fasting. Also during stage 1 and 2, your body's going to expel toxins and damaged cells every time you go to the bathroom. So if you notice that you're having more diarrhea, then there's no need to worry because that's just your body getting rid of the bad toxins. And then bad breath is also considered for the fast, but the good news is that there's nothing to worry about because it's just part of the detoxing process. And so now that we've talked about how the body interacts with fasting, let's talk about fasting and the physiological processes the bodies go through when we look at it through the lens of patients and doctors who work at fasting centers in both Russia and Germany. So now we're going to talk about the science of fasting. So this was a film that was made by Thierry Sylvie, who's a French film director, and this was under the same name, called The Science of Fasting, which was a documentary that came out on March 12th of 2012. And in this documentary in particularly, you're actually going to be looking at how fasting can affect the body physiologically, and you're also going to see how it affects the patients who are doing these fasts. So in Russia, fasting has become a part of public health policy, and it was studied for 40 years in the former Soviet Union. And so, as you can see at the bottom, right here, this is Boryashchinsk, and this is one of Russia's fasting centers. And so if you're a patient here, then you'll actually go into this center, and you'll be required to have to do a water fast for 12 days. Some of these fasts might last for 3 weeks, depending on the severity and duration of the disease. So depending on how long you had the disease, or how severe it is, then you may have to stay there a little bit longer, and you may have to do a water fast for about 3 weeks longer. So also during this time, medications for chronic conditions stopped after 2 or 3 days, and so there are possibly a couple of reasons for why they did this, and so they didn't really go into this in the documentary. But I believe that they did this because, number one, they obviously don't want you to be eating anything since you're fasting. And as we know, if you put something in your mouth when you're fasting, like any kind of, no matter if it's food or whatever, then you're going to be breaking it. The second reason I believe is because when you're fasting, you're actually going to be experiencing some symptoms for the first part of it. So depending on everybody's body is going to work differently, so depending on who you are and stuff, your symptoms may be more severe than others, and they may be less severe. But if you're on the more severe spectrum and you're taking medication at the same time, then it's more than likely that you're gonna have a pretty hard time getting through your fast, because you'll be dealing not only with the side effects of the fasting but also with the medication. So you're probably gonna be in for a pretty rough ride, since you'll be feeling pretty sick. And so also during this time, doctors actually looked at the patient's vitamin levels. And the reason they did this was because people believe that when you're fasting, you could actually have a higher risk of nutrient deficiency. However, the results of the test were that even though the patients experienced losses in vitamin C, D, and E, these losses weren't critical. And so, yes, they did lose a couple of these vitamins, but they weren't major to where they had to stop the fast or they couldn't go on and stuff. It wasn't major, and so it was only like tiny losses. And and so and so a majority of patients also come to these fasting centers to seek help with diabetes, rheumatism, allergies, hypertension, etc. And so symptoms disappeared after one or more courses of fasting, and hunger pains actually stopped after 1 or 2 days. So also during a fast, the body is going to be experiencing an acidosis crisis, which is basically where it has to live off its reserves. So again, this is where the body switches over from living off its glucose reserves to its fat reserves. And so on the third day, this is actually going to bring the process of elimination and detoxification. However, there is going to be a consequence to this, because you're gonna end up not feeling well. But the good news is that your body is going to start cleansing itself, and you'll get better eventually. So also urine samples were also show that the mode of nutrition will make the acidity of blood increase. So depending on when you ate prior to your fast, that would either increase the acidity of your blood, or decrease it. So you may also experience severe pain, but that won't last long. And so it's kind of bound to last around 24 to 36 hours. And then after a day of fasting, your glucose supply in the blood is used. And so glucose is made from protein, which can be found in the muscles. And so what happens is that your body will draw on the fat reserves to temporarily replace glucose, because it's still going to get some of that protein in there. Your body's still going to go after some of that protein. But again, it still needs the fat reserves. So until then, it's going to use those muscles to help replace the glucose. The glucose that's kind of like going down a little bit. And so also these are known as ketone bodies. And so again, with fat, it's going to be turned into simpler molecules. And because it's going to be turned to a simpler molecule, that's going to be known as a ketone body. So remember those ketone bodies we talked about? Well, as I said before, they will act as a food supply for the brain, and then through gluconeogenesis, the liver will turn fat into ketones, and then the body will find a new equilibrium. As a matter of fact, Russian doctors at the fasting center recommended 2 to 3 hours of exercise daily. So also the kidneys, intestines, and liver, lungs, and skin also start to detoxify. And so fasting patients may also notice how the sun can influence the body, and they may experience psychological hunger on the third day. So psychological hunger is basically where you're craving food just based off of emotion, basically. Like, you're not really hungry, but just like you're hungry because you're either thinking about it or you're just thinking about other emotions. So after the third day, the senses are sharpened and euphoria sets in, because remember, we have serotonin running through us at this point. And so about 60 years ago, researchers actually couldn't go to the SU or the Soviet Union to do studies on fasting. And so they actually had to do them in secret laboratories far from the West. And so one man that actually contributed to the study of fasting, even though he wasn't actually part of like the secret laboratory thing, he's actually a psychiatrist named Yuri Nikolaev. And so one day he was working and he saw that one of his patients wasn't eating. And so instead of doing the usual protocol where they ask your patients to eat something, he decided to let the patient not eat anything. He decided to just let the patient not have anything to eat, and eventually that patient recovered. And so Nikolaev actually treated schizophrenia, depression, phobias, and obsessions using the fasting period of 25 to 30 days, and sometimes 40. So even though this was actually pretty popular, and even though this was actually working, doctors actually criticized Nikolaev's fasting method, and so he decided to establish his own research program. And what this research program did was that it established a correspondence between changes in the body and improvement in the patient. And so, according to Dr. Gerbish, who's a psychiatrist of the Moscow Psychiatric Institute, he states that fasting has a stimulant and antidepressive effect. So, according to Dr. Gerbish, the stimulant takes place during the first week of fasting, and an antidepressive takes place during the first week after starting to eat again. He also states that third type is a sedative effect, which is observed after the crisis of acidosis or an acidosis crisis. So Nikolaev actually ended up treating 8,000 patients with fasting, and he saw improvement in 77% of cases. And 6 years later, the 47% maintained improvement. Nikolaev also noticed that patients who had hypertension, asthma, eczema, arthritis, etc. saw improvement. And then in 1973, the Ministry of Health became pretty skeptical because, again, fasting this was still 1973, so a lot of research still wasn't done on fasting, and so that's when the Ministry of Health actually became pretty skeptical, and because of that skepticism, they actually launched a campaign to see direct results. So the task of finding out more about fasting was handed to a handful of doctors, including two military doctors, Dr. Kokolsov and Dr. Maximov. So for Dr. Kokolsov, he knew nothing about fasting and used two objectives. One was to see if the method worked, and the other was to explain why. As for Dr. Maximov, he decided to study the secretions of the stomach, liver, pancreas, and intestines, the bacterial profiles, the levels of immunity, and the exchange of minerals and vitamins. So during this investigation, researchers actually made a list for the indications and non-indications for fasting. So for the indications, this basically meant that for diseases that were on the indications list, this meant that those diseases could possibly be treated with fasting, whereas if it ended up on the contradictions list, then those diseases couldn't be treated with fasting. However, let me remind everybody that this list was made in 1973, and so since 1973, more research has been conducted into finding out what fasting can cure. And so some of the diseases that ended up on the contradictions list may actually end up on the indications list today. And so first, let's start with the indications list. So the earliest indications for fasting would be for bronchial disorder, cardiovascular disorder, gastrointestinal disorder, endocrine disorders, digestive disorders, bone and joint disorders, and skin disorders. And then for the contradictions, we have cancers, tuberculosis, type 1 diabetes, thrombolipidus, anorexia, and chronic hepatitis. And like I said before, some of the diseases that ended up on the contradictions list could actually move over to the indications list since there has been evidence to show that fasting could actually treat cancer and as well as type 1 diabetes and such. And so this is just an example of a very early example of what the scientists thought what couldn't be treated and what could be treated by fasting. So fasting also causes a state of stress, which activates cytogenesis, or recovery mechanisms, as autoregulatory processes. And the majority of the time, these autoregulatory processes are inactive, mainly because of our lifestyle. And so food deprivation causes stress for the body. And so when it's triggered by the stress, the body sets off an alert that affects hormonal and urine endocrine changes. And hormones start to mobilize the body's reserves, and some also have an anti-inflammatory effect. Also, during a fast, the patient's blood composition levels also improved. So this included their glucose, cholesterol, triglycerides, and insulin. Also, the energy expenditure of the body also decreased, and the heartbeat also started to slow down, and their blood pressure also dropped. Also, the digestive system at this time goes into a state of rest as well. So that way all this can happen. So according to the documentary, Professor Osanen, who specializes in bronchial asthma, has treated 10,000 asthmatic patients through fasting, and since he's been in practice, there has been no accident in 40 years. So according to his research, he actually identifies changes in the cells in the lung mucosa. And if you look at the video, there's this one segment where they show a picture of the cells in the lung mucosa that are black. And the reason that they're black is because they're filled with histamine. And so, according to the documentary, after 12 days of fasting, there was no more histamine, but instead that histamine was replaced with lipids that filled the cells, and the cells were actually a clear white color now. And so research teams have actually studied, and so Osanen's research team has actually studied the general changes in the body and local changes as well. And what they noticed was that in the patients who fasted, they saw the disappearance of substances, which led to inflammation and edema. Also, Osanen's study also analyzed 1,000 patients after 7 years improvement persisted for 50% of patients. So what happens is that after they're done with their fasting, he actually gives them advice on the appropriate eating habits that they should follow. And so about 10 to 15% were completely cured because of their fast. So now we're going to be looking at Germany. So in Germany, 15 to 30% of the population claims to have already fasted. And so in the background right here, this is Böttinger Wilhelmi, and this is actually the oldest fasting center at Lake Constance. So about 2,000 people stay there every year, and they come to seek relief from chronic illnesses and seek prevention from illnesses such as hypertension, diabetes, and obesity. And so basically, when you watch the video, you're gonna actually see some testimonies from some of the patients. And one of the patients was Urine Ball, and so Urine Ball was actually a salesman. And whenever he traveled, he always tasted the food and the drinks from the places he traveled. And so when he came back from a trip one day, his doctor told him that his liver had actually grown 70 centimeters. And so that's when he told him to do some fasting. And then that's when he was sent to Böttinger Wilhelmi. And according to Ball, his experience there was pretty good. He said that that during the first week of treatment, his liver started to shrink. Back to its normal size, and then his blood test came back good, and his counts actually went back down to 0. And basically that's just his experience as a patient. You can watch more of the video, and he'll tell you more about it. But fun fact about this center, this was actually named after Dr. Otto Buttinger, who was actually a military captain, but this place was named after him. He actually recommended a soup that a person could take twice a day in order to relieve acidosis symptoms. And so also, one thing to know about this is that when you come to this fasting center, the treatments usually last between 1 and 3 weeks. So another story is from Pauline Valajay, and so basically she suffered from severe rheumatism, and she decided to fast for 12 days. And so according to her, her rheumatoid medications exhausted her, and she noticed that when she was fasting, she actually noticed that she had a little bit of an energy boost, but it wasn't an energy boost that made her like bounce off the walls, but you could tell there was a difference, and so she could tell that her body was healing her. So according to Dr. Drinda, when trying to heal arthritis, there needs to be a need for less steroid drugs. Side effects of these drugs may not be negligible, and we talked about earlier about why they may not be negligible. And so he also states that eating too much or non-quality food after a fast can be dangerous. The body has to get used to a new environment slowly. And so, as you can see right here, this is Berlin Charity Hospital, and in this hospital, there's actually a floor that's dedicated to patrons being treated by fasting. So there's actually a lot more hospitals that are adopting this form of healing in Germany. And so there are places that are recognizing fasting more, but just taking more time, a little bit more time and more research just to get there. So according to Dr. Michelson, who's the head of service of Charity Hospital Berlin, he states that he and his colleagues found the presence of epinephrine, dopamine, and leptin in patients who fasted. He also says that hormones that have a strong regulatory influence on the metabolism also influence movement. So this picture right here is the hormone that we've been talking about for a while, and that's serotonin. And as I said before, when you're fasting, your body is going to focus on more of its functions, such as hormone release, and that's actually one of the hormones that gets released during a fast. And so when serotonin is released, that means that it actually meant that the patient's mood actually improved when fasting. So patients also experience the reduction of pain and improved sensitivity of insulin receptance. Yeah, so also the doctors found that fasters are more likely to adopt a healthier lifestyle after a fast. And so basically, even though fasting is getting a little bit more recognized, it still hasn't really made like a headlines. Still hasn't really made any headlines, just because there is unfortunately no funding for any granted studies on fasting. And so there are some studies out there about fasting. But they're very limited, just because there isn't enough funding on fasting research. So, with the majority of people, whenever they hear about fasting and whenever they think of food deprivation, they think of starvation. And so basically, that's actually a valid concern, because obviously your body's going to be going without nutrition for quite some time, and for people that don't really know a lot about fasting, this is a valid concern for them. However, there have been researchers that have actually studied the effects of fasting for a long time. Well, and their subject was actually the emperor penguin. So, according to this documentary, the male emperor penguin actually practices fasting spontaneously. And so, if you guys remember those documentaries, if you guys remember watching March of the Penguins, if you remember that one scene where the mothers leave to get food, and the fathers have to watch their food, have to watch their eggs until the mother gets back. Well, according to researchers, the male emperor penguin can actually go without food for 4 months while watching the egg. And so Professor Yvonne Lemaho, who is a CNRS Strasbourg member of the Académie des Sciences, has actually studied the subject for years. And so, according to his findings, he states that fasting can be dangerous, since the body is speeding up on its resources. And so not only is it feeding up on its resources, but it's also feeding up on one very important resource of its, and that's its own reserves and protein. And so the muscles are composed of protein. And so what happens, that protein disappears that's when death happens. And we're going to be investigating that further throughout this presentation. But basically, remember when I said that to make glucose is that when your body makes glucose, it has to go to the protein first. Well, if your body's eating up all that protein for quite a while, and let's say, for example, that there wasn't any that you were only living on protein only, then there could be a possibility that you could actually die from fasting. However, Professor Yvonne actually states that there is one solution that the body came up with to prevent this from happening, and that's using its fat reserves. So what Professor Maho decided to do was that he decided to do a little test to measure the amount of proteins used by penguins during a fast. And so when the results came back, he found out that the proteins provided only 4% of energy expenditure. And so yes, if a person lived on proteins only during a fast, there is a likelihood that they could die. However, the body supplied itself very good, because he also found out that fats actually made up 96%. And so the conclusion was that the body actually saved its proteins. And so the penguin body actually economizes on protein and introduces lipids. And when this happens, the fat reserves can last for 100 days, and they can be depleted slowly. However, when 80% of fat is gone, and the proteins are no longer saved, and that's when you hit phase 3, which is where you must eat. So Maho also studied rats, and he actually weighed the rats daily, and their urine was sampled, and he found out that their proteins actually run out faster than penguins. And so in phase 2 of the fast happens, that's when rats actually save their proteins. So Maho states that if the mechanism is common, it has existed since the beginning of time, and humans may actually have the same capabilities. And this may have also been a coping mechanism shaped by evolution, because again, we were hunter-gatherers at the beginning, and so basically we had to wait for our food, and so there could be a possibility that that gene that our ancestors used long ago could actually be encoded in us. So adult rats who are 1 meter and 70 inches of mercury have 15 inches of mercury of fat reserves. And so this is actually enough to last the adult rat 40 days. And so according to evolution, survival may have depended on periods of fasting. And so genetic history is more likely less used to eating every day than it is to fasting. And the memory of fasting should be in the rat's genetic code. So gerontologists, who are scientists at steady age, studied mice who had cancer and separated them into 2 groups. So basically how this worked was that one group was fed normally, while the second group was fasted for 48 hours. And so what happened was that Professor Walter D. Longo injected mice with high doses of chemotherapy. And this was not regular chemotherapy that you would give a human, because this was actually 3 to 5 times higher than those allowed in humans. And so this could actually cause devastating effects. And so what Dr. Longo found out was that the fasted mice survived, and while the mice on a regular diet died. He also noticed that mice who fasted moved normally, and their tissues weren't damaged, and their cognitive functions seemed intact. And so as for the mice who were on a normal diet, they actually had only a 35% survival rate, and their hearts and brains were affected. And so according to Dr. Tanya Dorff, who's an oncologist at Norris Cancer Hospital, she states that it makes sense to protect the body, maximize damage to cancer, and minimize harm done to the body. And so if you look at the video, you'll see that there are some cancer patients that are participating in a study where they see how fasting can affect chemotherapy. And one cancer patient was actually fasted for 48 hours, while others did it for 28 hours. And so prior to getting the chemo, the patients were upped with calories and proteins before each chemotherapy session. And so Professor David Quinn, who is the director of therapeutic trials of the Therapeutic Trials Program, he says that if they can show the public that patients have less toxicity after fasting, this could actually transcend the spectrum of cancer treatment. And so basically there's a story about a woman named Nora Quinn. So Nora was diagnosed with breast cancer, and she actually asked her oncologist to if she could do a fast. And so she said she could, but she had to undergo 3 chemotherapy treatments. And so when she started, and so prior to her chemo treatments, she would always fast. And when she got her chemo, she always felt good, and she didn't really experience that many side effects. And so eventually, her oncologist told her not to fast during her chemo, and Nora felt pretty sick. And so she actually started fasting again. And so she could definitely tell the difference because she felt she had less, but she felt she had less fatigue during the treatment, and she felt like she had less symptoms as well. And so Norris Hospital actually took a sample group of 10 and looked at their medical records and obtained an analysis from the test that they did, and the results were the same as those of the mice. And so the liver, heart, and muscle genes also experienced a change after 2 days of fasting. And what they noticed was that some of the genes were overexpressed while others were underexpressed. So with the overexpression and underexpression of the genes, these actually modifies the cell's functions, and in return, these actually protected normal cells. And so with the cancer cells, after 2 days of fasting, the genes of the cancer cell were actually expressed differently than those of the healthy cell. So as they mutated, they actually lost memory, and their protection mechanisms did not occur. And so the one thing that cancer cells thrive off of, actually the 2 things that they thrive off of are glucose and sugar. And so since the cancer cells couldn't live in a low glucose and low sugar environment, they became more sensitive to chemotherapy, and even without chemo, they died or became more reduced. And so, after the fall of the Soviet regime in the 90s, this actually disrupted the public health system, and so the course of fasting now had to be paid for, and unfortunately, this was too expensive for many Russians. And so, but as a matter of fact, Goryachnisk the Goryachnisk Sanatorium is the only place hours from the city that the state encourages the practice of fasting. Okay, so now that we learned about fasting and the science behind it, let's learn about fasting and how it can influence neurological disorders. Next we're going to be talking about fasting and neurological disorders. So this was written by Matthew C.L. Phillips in 2019, and he works at the Department of Neurology at Makoto Hospital in New Zealand, and he is very passionate to develop a clinically effective metabolic strategy that can enhance the defective mitochondrial bioenergetics function underlying a majority of disabling neurological conditions. His research aims to explore the potential feasibility, safety, and efficacy of metabolic therapies, such as fasting and ketogenic diets, to help lead to bodily improvements in those with neurological disorders. This study was under the title as Fasting as a Therapy in Neurological Disorders. So, fasting induces an altered metabolic state that optimizes neuron bioenergetics, plasticity, and resilience in a way that may counteract a broad array of neurological disorders. In so in animals, for example, it possibly prevents the formation of tumors, treats established tumors, and improves tumor responses to chemotherapy. So in human cancers, including brain cancer, fasting helps with chemotherapy-related adverse effects and may protect normal cells from chemo. According to this, it states that it could also improve cognition, stall age-related cognitive decline, usually slows neurodegeneration, reduces brain damage, and enhances functional recovery after stroke, and mitigates pathological and clinical features of epilepsy and multiple sclerosis in animal models. So fasting is also known as ad libitum feeding, or as desired feeding. Is characterized by 3 or more meals per day in modern society. So ad libitum feeding is basically it's basically just the average societal eating schedule where you have breakfast, lunch, and dinner. And so combined with a sedentary lifestyle, this may increase a person's risk of developing a chronic neurological disease. And so the one thing we should remember is that fasting shouldn't be confused with starvation, since chronic nutritional insufficiency or chronic nutritional insufficiency, which is neither voluntary nor controlled, and it may culminate in organ failure and death. So remember, fasting is fasting is voluntary. Because you choose when to eat and when not to eat, whereas with starvation it's involuntary, because even if, like, let's say for example that you're done fasting, but then you don't have any food with you because the food you don't, because of there might not be any food inside, that'll be starvation. So during evolution, organisms who were able to tolerate longer periods of time without food had a better chance at survival than those unable to. Also, due to evolutionary selection, pressure to survive environments with low energy has produced fasting-induced metabolic mechanisms conserved for millions or billions of years in humans. So there may be a possibility that through evolution we may actually have this gene imprinted in us that is actually very familiar with fasting. And because since our ancestors did it, then that means that maybe we have done it also. Then maybe we could do it also. With single-celled and simple multicellular organisms, they actually alter their metabolism during times of nutrient scarcity. So they have 3 different aims. Their first is to conserve resources, minimize damage, and enhance longevity. So let's look at Escherichia coli here. So, which will be at the top picture right here. So Escherichia coli, or also known as E. coli, is a type of bacteria that lives in our intestines and is found in some animals. And so scientists have found that when it's transferred from a nutrient-rich broth to a calorie-free medium, they undergo a series of metabolic changes that allow them to survive for 4 times longer than wild-type bacteria. So the same can go for Saccharomyces cerevisiae, which is a single-celled eukaryote, and so when it's moved from a growth medium to water, it enters a stationary phase that increases stress tolerance and doubles its lifespan. So the same can be said for multicellular organisms such as the Cardor habidus elegans, or the nematode, which would be right here, which transitions into a metabolic daughter state, resulting in a substantial increase in lifespan. So for lungfish, eels, snakes, and arthropods, they have actually evolved resistances to nutrient scarcity, partly due to a decreased resting metabolic rate. And activity levels. Also, some organisms increase their cognitive and physical activity levels when fasted, which improves their ability to seek and acquire food. And so remember when I said about that brain fog and stuff? Well, that can happen to animals too. So when you're fasting, you're actually increasing their cognitive and physical activity levels when fasting. So also with rodents, so with a test on rodents, it actually showed a decrease in the size of most organs, besides the brain and gonads. So the brain and gonads stayed the same size, but with the rest of the organs, this resulted in a maintained or improved cognitive and physical performance. So also in captive lions, they actually switch from a conventional feeding schedule to gorge and fast schedule. So this basically consists of 3 meals per week and having to show a reduction in maladaptive stereotypic behaviors such as pacing, increase in adaptive hunting-related behaviors such as sniffing and stalking. So with a gorge and fast schedule, basically you're putting the lion on basically the same schedule as as you would, but when it's not on that schedule, then you're actually decreasing its natural behaviors like sniffing and stalking, because again it's not eating all the time, and so when it's not eating all the time, there's no use for it to have those behaviors. So, like I said before, fasting shouldn't be confused with starvation, since chronic nutritional insufficiency, which is neither voluntary nor controlled, since it may culminate in organ failure and death. And so, with pre-agricultural humans, they actually endured regular periods of food scarcity. So, as a matter of fact, humans were actually hunter-gatherers for 2 million years. And so there are still hunter-gatherers out there today, but back in the day when people were hunter-gatherers, we actually literally had to wait for our own food, because we would go out hunting, and if we didn't catch, like, let's say that deer or a rabbit, then that means that'll mean that we'll have to wait probably like another month or so, or even another month or so before like we catch another meal. So basically, that's when our bodies had to adapt, and they had to adapt themselves, and they had to say, okay, you know what? Since I'm not going to have this X amount of food for a while, I need to find a way to produce for myself. And so that's how the body is like, and that's why the body is doing a fast, because it has to find a way to provide for itself. And so 12,000 years ago, the transition to agriculture occurred. And so at this point, with post-agricultural humans, they may have not had enough time to fully adapt to a continuous food supply that was provided by farming, which may explain intra-voluntary fasting practices by a majority of civilizations on Earth. And so basically, with agriculture popping up, it's like a lot of humans bodies didn't really know how to adapt to it, and because they didn't know how to adapt to it, that meant that they were kind of like trying to like stick with what they've known for a while. So if the body was like so basically the body was comes like saying, well, you know what, I've been doing this whole fasting and waiting thing for like a while, and so I'm probably just going to stick with this. And so ancient Romans also believed that eating more than one large meal per day was unhealthy. So let's say, for example, that an ancient Roman went into this time machine. He was transported to the 21st century. Okay, so obviously he would see like a lot of people having meals for like having more than one large meal per day, such as let's say, for example, pizza. So if you saw like two people having more than one large pizza and stuff, and then that you'll be still considered that problematic, because back in his day, that would be seen as not very healthy, with having more than one large meal per day, or not even pizza. But let's say if you had a pizza and then spaghetti with meatballs, and also a giant hot fudge sundae all in one day. Okay, so those are very large meals. So that'll be considered problematic also. And so basically that's just what the ancient Romans were taught back then, was that if you had more than one large meal per day, then that'll be really unhealthy. So in the 1800s, American physician Edward Dewey adopted the view that all disease stemmed from excessive eating. And so basically he said that if we constantly ate every day, like if we constantly eat every day, there could be likelihood that our bodies could catch a disease. And so in the 1900s, German physician Otto Buchinger, who was the first person to document the beneficial effects of fasting in many diseases, wrote that fasting was the most effective treatment. And then let's skip over to the 2000s, where Walter Longo, who we saw in the Science of Fasting, who's a biogerontologist and fasting researcher, suggested that fasting activates multiple longevity programs, which may lead to an extended lifespan and health span. And so the fasting pattern in modern society is 3 or more meals a day, which increases the prevalence of obesity, type 2 diabetes, and a variety of disabling neurological disorders. So basically what scientists are saying is that basically with the whole 3 or more meals per day schedule that we have, there could be a possibility that this could be linked to, again, prevalence of diabetes, the prevalence of obesity, type 2 diabetes, and a variety of disabling neurological disorders. So what they're saying here is that our 3-day meal schedule could possibly be linked to some of these diseases. So now we're going to talk about fasting mechanisms. So fasting allows coordinated alteration. So by coordinated alteration, this means that metabolic and transcriptional mechanisms may influence neurons. Also, these alterations may include neuron bioenergetics, plasticity, and resilience to stress, culminating in a maintained or even enhanced performance. So in a way, the alterations that your body is making may actually help with your enhanced performance of neurons. So in the first 12 to 36 hours of fasting, the body enters ketosis, in which the body experiences low blood glucose levels, exhausted liver glycogen stores, and hepatic production of fat-derived ketone bodies, which serves as an energy source for the brain. So the liver is also the primary site of ketogenesis, which we talked about earlier, but the brain astrocytes also generate ketones. So even though the liver is involved with gluconeogenesis, the brain astrocytes also generate ketones as well. So several days of beginning the fast, the ketones become the brain's preferred fuel source, providing up to 70% of energy requirements. So also ketones provide a more efficient source of energy or per unit oxygen in muscles and in the brain, which in return enhances neuron bioenergetics and cognitive performance. An example would be where rodents were subjected to ketone ester for 5 days and exhibit an improved spatial learning and memory. So now we're going to be talking about BHB, BDNF, and PGC1A, which are very important factors when you're fasting. So the primary blood ketone, which is beta-hydroxybutyrate, or BHB, serves an important signaling function. So the way this works is that it plays a signaling role by inducing a transcription of brain-derived neurotrophic factor, or BDNF, via its inhibition of histone deacetylases, or enzymes that repress BDNF. So the main thing that we want when we're fasting is that we want beta-hydroxybutyrate to come in and send in that signaling role by inducing a transcription of again the brain-derived neurotrophic factor, or BDNF. And the only way it can do that is if there's an inhibition or of the histone deacetylases, which are actually preventing from the BHB sending that signal. And so when you're fasting, the HDs are actually basically moved out. The HD enzymes are actually moved out of the way, and so because they're moved out of the way, they're no longer repressing the BDNF expression. And so basically, what the BHB can then send that signal over, and then the BDNF can be activated. So what are BDNF's functions? Well, it stimulates mitochondrial biogenesis, it maintains synaptic structure, it spurs production and survival of new hippocampal neurons, and enhances neuron resistance to injury and disease. So now we're going to be looking at PGC1A. Now, what is PGC1A exactly? Well, it's a central inducer of mitochondria biogenesis. And so basically what happens is that it increases the mitochondrial biomass, which in turn enhances the neuron bioenergetics and enables synaptic plasticity. So with PGC1A, basically what it's doing is that it's going to induce mitochondrial biogenesis, or biogenesis. It's going to help the mitochondria grow, and then it's going to help to increase the mitochondria biomass, which in return enhances neuron bioenergetics. So it's going to help to enable better neuron function. It's going to make them it's going to make them have more synaptic plasticity. So PGC1A also modulates composition and function of the mitochondria. And so, for example, with the muscle mitochondria that is isolated from transgenic mice that ectopically express PGC1A, they exhibit an increased respiratory capacity compared to a wild-type control. So this also stimulates the formation of mitochondria with altered intrinsic properties that both have a positive effect on neurons or on neuron bioenergetics. So in humans, fasting for 3 to 5 days decreases blood glucose levels by 30 to 40%, and as a result, it inhibits glycolysis. Also, fasting on alternate days for 3 weeks decreases insulin levels by 50 to 60% on a fasted day. 3 to 5 days of fasting in humans results in a 60% decrease in insulin growth factor, or IGF-1 growth factor, in animals. So this may increase to a 5 to 10-fold increase in IGF-1 binding protein, or IGF-BP1, which is one of its main binding proteins, and a 2 to 3-fold increase in growth hormone GH rises to preserve muscle mass. So fasting also prevents the development of chronic excessive and deregulated glucose metabolism while preserving insulin sensitivity and growth factor signaling. This may benefit neuron bioenergetics. This may also have an influence on cell synthesis and degradation processes, since regulators are mTOR and an AMP activated protein kinase, which we are getting ready to talk about right now. So now we're going to talk about mTOR and AMPK, which also play an important part in fasting. So let's start with mTOR first. mTOR stimulates protein synthesis and growth. So basically, what protein synthesis is that you're basically creating new protein cells. So mTOR helps with this by stimulating the body to create new proteins, and also helps to stimulate growth. And so AMPK is used when energy is low. So the way this works is that it actually downregulates mTOR to minimize energy consumption and stimulates autophagy. And during this process, it makes a pathway to clear misfolded proteins and damaged organelles to recycle nutrients and bolster energy production. So basically, what AMPK is that it comes to just minimizes the energy consumption of the body in order to stimulate autophagy. So think of AMPK as like a light switch. And MTOR, AMPK and MTOR are like light switches. So when your body's getting ready to go into autophagy mode, the AMPK is going to turn that light switch off. And when that light switch is turned off, that's when MTOR is going to minimize its energy consumption, and soon a pathway is going to be made for any misfolded proteins and damaged organelles so they can be recycled and it can bolster energy production. So by turning on the AMPK, you're actually saving energy for your body, like you would save energy for a building when you turn the light off. And so fasting suppresses mTOR and elevates AMPK, and as a result of this limits nutrient consumption and growth in favor of autophagy and survival. This may also use fasting responses in neurons. So fasting also influences fat metabolism by altering the hormonal activities of leptin, adiponectin, and ghrelin. Now we are going to talk about leptin. adiponectin, and ghrelin. So leptin is a hormone that has a pro-inflammatory state. And so leptin is good because basically it's also leptin is a good thing to have because again, with inflammation you're able to like burn stuff faster, and so with the help of your fat cells and leptin you can help burn your food faster. So you can help burn your food. But the problem arises when you have too much leptin in you. So if you have too much leptin in you, that's going to cause inflammation. And so that's when adiponectin comes in. So adiponectin is associated with an enhanced insulin sensitivity and suppressed inflammation, while ghrelin is associated with an enhanced insulin sensitivity. So this may stimulate the hippocampal synaptic plasticity and neurogenesis. So the way these three factors work is think of a Batman cartoon. So pretend that leptin is pretty much like the Joker. So you know how the Joker was once the good guy, but then all of a sudden he comes to like gets loose and he starts to like get loose, and he starts to get out of control of his power. And so leptin comes like the Joker. Even though leptin's a good thing to have, if it isn't maintained properly, then it can get out of control. While adiponectin and ghrelin are Batman and Robin. So when you fast, you're actually decreasing leptin, and in return, this is going to increase adiponectin and ghrelin. And so when you're fasting, you're actually taking away the Joker's powers or leptin's powers to cause more inflammation. And in return, this is going to help Batman and Robin to restore peace to the city of Gotham, or it's going to help increase adiponectin and ghrelin. And so this may be beneficial for neuron bioenergetics and maintenance of neural pathways. And so with the neural pathways and bioenergetics, just think of it as the cities or buildings that the Joker destroyed while he was in power. And so when adiponectin and ghrelin come in, you're actually rebuilding those buildings or the neural bioenergetics and neural pathways, or like the highways and the buildings. And if you take a look at this picture right here, you'll see right here in this yellow oval, it says leptin. Okay, so with leptin, here's the stomach right here. So in the stomach we have leptin. In the stomach we have leptin, and so then we have the hypothalamus. And so the way this works is that the hypothalamus indicates food intake, and so there's a food intake, and then it goes over to the stomach. And then what happens is that there's an energy expenditure, so that food is giving us energy, and through the adipose tissue. But however, if there's too much leptin, then that means that's going to lead to inflammation, neoplasia, which means you're going to have inflammation in your bowels right here. Now we're looking at the issue of inflammation in the neurons. So fasting suppresses inflammation, and as a result, it reduces the expression of pro-inflammatory cytokines such as interleukin and tumor necrosis factor, or TNFA. So if you look at this picture right here, we have all these different inflammatory cytokines coming at this neuron, and as you can see, this red circle right here, that's going to represent the inflammation that all these cytokines are causing. But when you're fasting, apparently this is gonna like reduce the expression of the pro-inflammatory cytokines, and so the inflammation that these guys are causing right now, it's gonna basically their expressions, like their gene expressions, are gonna be reduced to where they can't cause that much inflammation. And so if the inflammatory processes also cause different neurological disorders, and so fasting to suppress neural and systemic inflammation may improve neuron survival in these disorders. So now we're going to talk about calorie restriction. So calorie restriction refers to a chronic 20 to 40% reduction in calorie intake with meal frequency maintained. Research shows that calorie restriction reduces chronic disease and lengthens lifespan in a variety of species. Studies in animals and humans show that fasting may benefit cell, including neuron metabolism, beyond a calorie restriction. So mice fasted on alternate days can eat twice as much on feeding days, since their net weekly calorie intake remains similar to mice fed ad libitum. The lack of overall calorie restriction has former displayed beneficial metabolic effects compared to the latter, including improved glucose levels and insulin activity and enhanced resistance to neurotoxin ketonic acid. So studies involving overweight and obese non-diabetic humans have shown greater improvements in insulin sensitivity in fasted individuals compared to their non-fasted calorie-matched counterparts. So during a 5-week trial in men with prediabetes, scientists compared a fasting regimen containing sufficient overall calorie intake to prevent weight loss. So against the control group with a regular schedule. So both matched for calorie intake, but however, the fasting group experienced greater improvements in insulin sensitivity and other measures of metabolic health. So 12 to 36 hours of fasting, there's actually going to be a switch that goes from utilizing carbohydrates and glucose to fatty acids and ketones as major cellular fuel sources. So also during the fasted state, a switch goes on which helps with autophagy and survival pathways in neurons, whereas during a fed state, the switch is off, emphasizing remodeling and growth pathways. So when you're fasting, you're actually helping with autophagy and survival pathways in neurons. So you're constantly building survival pathways in your neurons, whereas if you turned off your switch after you broke your fast, you're actually emphasizing that remodeling and growth pathways. So in a way, you're actually growing those survival pathways more, even after you stop fasting. So fasting also capitalizes on each sequential bioenergetic challenge by setting the stage for a stress-free cell recovery phase, which means switching intermittency that provides an advantage for neuron metabolism. So basically, like I said before, fasting basically helps with bioenergetics, and it's basically setting the stage for a stress-free cell recovery phase. So fasting is helping your cells recover also, not only your body and your organs, but also the cells in those organs. And so switching intermittency also helps to provide the advantage for neuron metabolism. So by switching on and off with autophagy, you're actually helping with your neural metabolism. So now we're going to talk about the intensity of the food and drink restrictions. So intensity refers to the amount and type of food and drink that may be permitted during the fasting periods. Intensity ranges from complete omission of all food and drink or pure fast to a minimal intake of specific meals aimed at maintaining the fasted metabolic state. So with a water-only fast, this actually omits calorie intake and provides an adequate hydration and can be extended out to several days, weeks, or months, which provides adequate salt and micronutrients only if it's providing adequate salt and micronutrients. So here's the thing about this is that with the salt and micronutrients, I'm still studying Now we're going to talk about the frequency and duration of fasting periods. So most humans can survive fasting periods of 30 days or longer. Evidence shows that restricting the eating window to the morning or middle of the day produces superior effects on body fat and insulin resistance compared to the late afternoon or evening eating windows. So periodic fasting is where you extend the fasting period from 2 days to 3 weeks in duration. This may produce more pronounced and metabolic changes. Fasting periods lasting several months to over a year have been documented in humans as well. Now we're going to be looking at the evidence supporting fasting for neurological disease. Fasting can prevent and treat metabolic syndrome, which is another major risk factor for a variety of neurological disorders. Fasting can prevent and treat neurological disorders in animals, However, there are less studies that are available for humans. So, with fasting metabolic syndrome, or FMS, this consists of abnormal obesity, insulin resistance, and hypertension. So, with fasting, this actually alleviates key abnormalities of metabolic syndrome in animals and humans, resulting in beneficial effects that are similar, sometimes superior, to those observed with calorie restriction. Phillips also states that rodents on fasting regimens experience lower body weights compared to rodents fed ad libitum, with long-term or over 20 weeks fasting regimens generally producing significant weight loss. So just to add as an extra note, the lower body weights were actually a result from reduced fat mass and not lean mass. And so Phillips also found that fasting cures type 2 diabetes in rodent models, which are not due to calorie restriction, given that TRF animals consume the same overall calories. It also produced beneficial effects on insulin resistance, superior to those induced by even severe calorie restriction. Fasting also produced beneficial effects on insulin resistance that are superior to those induced by even severe calorie restriction. So, an example would be where rodents were put on an ADF regimen, and the results showed that they could maintain similar body weights compared to rodents fed ad libitum. While the former shows improvements in glucose levels and insulin activities that are greater than those that were demonstrated by rodents on a 40% calorie restriction. And also, the study also shows that the former displayed an anti-diabetic effect, whereas the latter did not. So basically, what this is saying here is that when it comes between fasting and calorie restriction, sometimes fasting may work better than calorie restriction, a majority of the time. So ADF also decreases heart rate and blood pressure in rodents within days, and it continues to decrease until stabilizing lower levels start by the end of the month. So afterwards, it actually remains low on both fasting and feeding days. So rodents on ADF regimen also show increases in heart rate variability and cardiovascular adaptation to an immobilization stress. Heart, blood pressure, heart rate variability, and cardiovascular stress are brought on by BDNF, which enhances cholinergic activity of brainstem cardiovagal neurons. Rodents on ADF with 10 to 20% calorie restriction show greater decreases in resting heart rate than rodents maintained on chronic 40% calorie restriction. Now we're going to talk about fasting as a therapy in the metabolic syndrome through the lens of human studies. So fasting regimens in humans are not as consistent as in animals, and so they can be short-term or under 6 months, in which fasting regimens generally lead to weight loss in overweight and obese individuals. And so, according to a study, overweight and obese people who were placed on a 2 to 6 months fasting regimen actually demonstrated a 3 to 16% reduction in body weight compared to controls with regimens over 3 months, which are more likely to show a clinical weight reduction of 5 kilograms or more. And so, as you can see here with fasting and calorie restriction, they could produce similar degrees of weight loss. Although some studies suggest that fasting regimens may be superior to a 20 and 25% calorie restriction. And so basically, what this is both saying overall is that like calorie restriction and fasting can both do things, but there may be times where fasting can be more superior than calorie restriction. So fasting may also be more effective than calorie restriction at retaining lean mass, and it's also known to reverse type 2 diabetes. And so another thing to remember is that when fasting may be more effective than calorie restriction at retaining lean mass. So 6 to 24 weeks of an ADF, or 20 days per week, actually induces a significant decrease in blood pressure, which would be about 3 to 8% systolic and 6 to 10% diastolic in the context of weight loss. Also, periodic fasting is effective at reducing blood pressure in hypertensive individuals. Systolic blood pressure falls by 20 to 60 millimeters of mercury within 1 to 2 weeks. Fasting and calorie restriction also shows similar effects on blood pressure reduction. Now we're going to talk about cancer. So cancer cells have metabolic alterations. Their most notable is an elevated rate of glycolysis despite the presence of normal oxygen concentrations known as the Warburg effect. So the Warburg effect simply states that with cancer cells, they prefer to live in an environment with aerobic glycolysis, whereas with normal cells, they'd rather live in an environment with oxidative phosphorylation. And so basically, cancer cells have to live in an environment with glucose because that's sugar, and cancer cells thrive on sugar. However, the Warburg effect is inefficient at producing energy. So since it is inefficient at producing energy, it relies on an increased rate of glucose uptake by cancer cells, and it's actually a common feature to over 90% of malignant cancers. Also, some cancer cells are reliant on amino acid glutamine for growth and proliferation. The dependence of glucose and glutamine result from deficiencies in mitochondria, number, structure, and function that are characteristics of most cancers, as well as reprogrammed cell metabolism supportive of unchecked growth and proliferation. And so, because they're dependent on glucose and glutamine, you're going to be more in the route of suffering from deficiencies such as mitochondrial number, structure, and function that are characteristics of most cancers. And so, because of that, it's going to be you're going to have a reprogrammed cell metabolism, and supportive of unchecked growth and proliferation. And so, even though they're thriving off of glucose and glutamine, you're also going to suffer some deficiencies. And so, also cancer cells, they exhibit a deregulated hyperactive insulin IGF-1 and mTOR signaling and dysfunctional autophagy. And so with the IGF-1 and mTOR, we all remember what mTOR is. mTOR is responsible for protein synthesis and growth. And so since the cancer cell has deregulated hyperactive insulin IGF-1 and mTOR signaling, that means that its protein synthesis and growth isn't going to work out very good for it, because again, it's very deregulated, and it's just like the cancer cell in and of itself is basically very, very dysfunctional. And not only is it going to have a hard time with the mTOR, but it's also going to have a hard time with dysfunctional autophagy. And so dysfunctional autophagy, that means that if it's not eating, or if it's not being fed like any glucose, then it could actually put into like a little bit of a tailspin. So in 1914, Roos, who was a scientist, reported a reduction in food intake that decreased cancer in rodents. So a number of studies show that calorie restriction regimens reduced tumor incidence by perhaps 75% in rodents and 50% in rhesus monkeys. So calorie restriction may actually be reduced. So they thought that this may partly relate to the fact that calorie restriction reduces blood glucose and growth factor availability and dampens cancer cell growth. Fasting regimens also prevent tumors in most rodent cancer models, and results are more variable in comparison with calorie restriction. So, depending on the specific type of fasting regimen that was used and the nutrients received during the refeeding periods, this could actually influence tumor prevention. Also, fasting creates large amounts of ketones, which cannot be used by cancer cells and may inhibit growth. And so this could actually be, fasting could possibly be more superior to calorie restriction in this case. Studies also show that fasting reduces glucose, glutamine, and growth factor availability to a greater extent than calorie restriction, which deprives cancer cells of their major fuels and disrupts their ability to proliferate. So an example would be where rodents were inoculated with tumor cells, and so about 50%. So now we're going to talk about cancer and fasting as a therapy in cancer and human studies. So according to Phillips, fasting may hold a promise in treating established cancers in humans, including brain tumors, as well as cancers that may metastasize to the brain. So according to a case report involving glioblastoma patients, they actually used water-only fasting requirements in conjunction with other forms of cancer treatment and had reported favorable outcomes with smaller tumor growth. Another study that involved 10 patients, 1 with lung cancer and 4 with breast cancer, fasted before or after chemotherapy, and this actually decreased chemotherapy-related adverse effects, which included weakness, fatigue, and gastrointestinal upset. A second study involved 13 women with breast cancer, and it was actually a randomized trial. It was actually randomized, and they got the decision to either do a 24-hour fasting before or after chemotherapy, or ad libitum feeding. And so this demonstrated that the fasting was well tolerated and prevented chemotherapy-induced decreases in red blood cells and platelet counts, and possibly protected normal cells from DNA damage. So in study number 3, 20 patients, including 1 patient with lung cancer and 5 with breast cancer, fasted for 48 hours or longer before and during chemotherapy, and this protected cells from DNA damage. Now we're going to be talking about neurodegeneration. So in Huntington's disease, Parkinson's disease, and Alzheimer's disease, all 3 of these diseases exhibit an impaired neuron bioenergetics, glucose metabolism, and neurotrophic factor signaling. So there's actually a reduced expression of PGC1A, or the mitochondria regulator, along with an associated decline in mitochondria biogenesis and function. So basically, with a neurodegeneration disease, it actually affects the mitochondria because, again, it's affecting its neuron bioenergetics, its glucose metabolism, and neurotrophic factor signaling. And so it also reduces the PGC1A expression, and along with mitochondrial biogenesis and function. And so in diseases such as PD and AD, the respiratory chain is impaired, especially in PD, which demonstrates a marked deficit at complex 1. And so PD and AD show impairments in neural glucose metabolism and insulin signaling, especially in AD, which is characterized by brain insulin deficiency as well as resistance, thus leading AD being described as a form of brain-specific type 3 diabetes. So according to this study, fasting improves cognition and prevents cognitive decline in non-neurodegenerative animal models. Also, rodents on fasting regimens display an enhanced cognitive performance compared to those ad libitum. And so basically it just like when these animals were fasting, again they had improved cognition, and it prevented cognitive decline in non-neurodegenerative animal models. They also had enhanced cognitive performance compared to those who were on the normal feeding schedule. So TRF also stalls age-related declines in brain white matter integrity, energy production, and cognition observed in rodents fed ad libitum. So with mice on TRF, they actually showed an increased hippocampal BDNF levels, synaptic strength, and neurogenesis. They also showed improvements so these improvements and conditions were mediated by BDNF. And so, mice with HD showed So the thing with this is that mice with HD showed deficiencies in stradial and cortical BDNF levels, in glucose metabolism, along with neurodegeneration and motor dysfunction. And so, if ADF is commenced early enough, though, BDNF levels increase, glucose metabolism normalizes, and neurodegeneration and motor dysfunction are delayed. Also, in PD mouse models, ADF protects against dopaminergic neuron degeneration and a loss induced by mitochondria toxin 1, methyl-4-phenyl-1,2,3,6 tetrahydropyridine, or MPTP, which results in improved functional outcomes compared to mice fed ad libitum. So, remember when I told you that in diseases such as PD and AD, the respiratory chain is affected? Well, when you're fasting, there's this hormone called MPTP, and it actually interferes with a complex of mitochondrial respiratory chain. And so it has a beneficial effect that may be due to ketones produced while fasting, and thus this could circumvent PD complex 1 defect via complex 2 dependent mechanism, and enhancing mitochondria bioenergetics. And so with MPTP, this is actually all this does basically just to help rebuild the respiratory chain. And so in AD mouse models, ADF helps to increase the hippocampal neuron resistance to neurotoxic effects of canic acid, which results in the improved performance in ADF that ameliorates age-related cognitive deficits that occur in transgenic mice expressing beta-amyloid precursor protein, penicillin 1, and Tau mutations. So now we're going to talk about fasting as a therapy and neurodegeneration in humans. So fasting is not studied in people with HD, PD, and AD. There is, however, indirect evidence provided by studies of ketogenic diets. So a lot of you may have heard of a ketogenic diet, but for some of you that may not know, a ketogenic diet is a high-fat, adequate protein, low-carb diet that forces the body to burn fats rather than carbohydrates as a primary energy source, mimicking a fasted metabolic state by generating ketones and inducing many of the metabolic mechanisms induced by fasting. So basically, a ketogenic diet is where your body's mimicking a fast. So this would also be known as an FMD, a fasting mimicking diet. And so in PD, so let's look at some case studies. So a case study involving PD patients, the ketogenic diet actually improved motor symptoms after 4 weeks. Of it. So this involved 47 people with a mild to severe PD, and it showed improvements in many of the most disabling, least levodopa, responsive PD non-monitor symptoms after 8 weeks of ketogenic diet. There's also another case series involving 15 people with mild to moderate AD, and they reported mild improvements in cognition after 12 weeks of the diet. So one possible explanation would be that even though brain glucose uptake is impaired in AD, that doesn't mean that the ketone utilization is not. Because remember, when you're fasting, your body isn't using any of that glucose anyway. And so when you're fasting, that's when your body's creating ketones. And again, ketones are not only for giving your body energy, but it's also for giving your brain energy also. So it could be a possibility that the ketones in the brain also help to make improvements in those patients as well. So now we're going to talk about strokes. So most strokes worldwide are ischemic and involve neuron loss, neural inflammation, neural network rewiring, and neuron functional reorganization. In animals, fasting prior to ischemic stroke helps with brain damage and enhances functional recovery. Rodents remaining on ADF prior to the occlusion of middle cerebral artery display show less brain damage and improved functional outcomes compared to those fed ad libitum. Mice on TRF for 3 months prior to middle cerebral artery occlusion show an increased neurogenesis in hippocampus and subventricular zones, and infarcts less than half the size of those seen in mice fed ad libitum. Rats maintained on TRF for 3 months before and after 70 days after global cerebral ischemia show persistent improvements in spatial memory compared to non-fasting controls. So the effects of fasting after an ischemic stroke has already occurred is So now we're going to look at fasting as a therapy and stroke through the lens of human studies. So unfortunately, human studies are lacking. However, scientists have found that fasting produces levels of pro-inflammatory factors such as a C-reactive protein, IL-6, and homocysteine, which may inhibit the formation of arteriosclerotic plaques, which are a common source of strokes in humans. So epilepsy is characterized by neuron hyperexcitability, and it's actually lending to an enduring predisposition to generating seizures. So unfortunately, despite anti-epileptic drugs and surgery, 1/3 of people continue to experience drug-resistant seizures. So mice on TRF have prolonged latency to seizure generation and a decrease in severity and frequency of seizures. And so when you fast, this may alter seizure protection by altering the activities of metabolic factors such as IGF-1, mTOR, and AMPK. So from this picture right here, you see how parts of the brain how some parts of the brain are lit up. Well, if you're fasting, then these lit up parts right here could go away, because that could be due to the IGF-1, mTOR, and AMPK alterations when you're fasting. So fasting was actually used to treat epilepsy since the era of Hippocrates. Also in 1911, Guelpa and Maria who were scientists, documented the effectiveness of fasting in the treatment of 20 people with epilepsy. However, there were no studies published for nearly a century. That was until a recent study was published, which involved a 2-month modified TRF regimen in 6 epileptic children with an incomplete response to ketogenic diet. And based on a report from that study, it stated that 4 of the 6 children experienced modest improvements in seizure control. Also, with both fasting and KD, they both showed an increase in BHB, which correlated to improved seizure control. They also both induced mechanisms that stabilized synaptic function. This study also showed that some fasted children experienced modest improvements in seizure control beyond KD. So now we're going to talk about multiple sclerosis. So multiple sclerosis is actually an inflammatory autoimmune mediated disorder that damages central nervous system neurons and axons. So as you can see from this picture right here, we have this person who's actually experiencing multiple sclerosis. And so from the left side right here, you can see that this is a healthy neuron. You see that everything's in order, and the axons functioning good. But then right here with this person, she has a damaged neuron, because as you can see, everything's right here is damaged, and so because of this neuron damage, she's going to be more sensitive to let's say to touching a hot beverage, whereas if she had a healthy neuron, then she wouldn't be as sensitive to touching it. And so this actually focuses on the gut bacteria and metabolites. And so they're both important regulators of T cell differentiation and enteric immune responses. And so, based on this study, this may suggest that dietary factors exert a strong influence on gut microbiome composition and metabolite production, which may contribute to the pathogenesis of MS. So now we're going to talk about fasting as a therapy in MS in animal studies. So fasting is beneficial in experimental autoimmune encephalomyelitis, which is an animal model of MS that involves inflammatory mediated demyelination and the death of oligodendrocytes. So in mice on ADS regimens, this ameliorates pathological clinical features of EAE, which enhances gut bacteria diversity and increases regulatory T cell numbers. Fecal microbiota transfers from the ADS mice to mice fed ad libitum, and it decreases the severity of EAE in the latter, indicating some of the benefits of fasting that may be mediated by gut bacteria. The alternate cycles of fasting mimicking diet, or FMD, which mimics fasting by providing standard amounts of food are severely reduced in calorie density, which also reduces clinical severity in EAE in mice, and includes complete reversal of symptoms in mice in 20% of them. Mechanisms underlying FMD and EAE include enhanced oligodendrocyte precursor cell generation and axon remyelination, with an improved regulation of autoimmune cells and pro-inflammatory markers. So now we're going to talk about the human studies for fasting as a therapy in MS. So fasting produces pathological clinical improvements in non-neurological inflammatory mediated diseases, which include rheumatoid arthritis and asthma. So as you can see right here, this is a healthy neuron, and so this is the nerve fiber. And right here, the nerve fiber is looking pretty good right here in this area. And this is the stomach cells, so they can protect the nerve fiber. But in a person that has MS, the scomet cells are actually exposed. So that means that this part of the nerve right here is damaged, and also the nerve fibers kind of has like this little circular thing on it compared to the healthy nerve. And so that's basically kind of sort of what a nerve would look like if it had multiple sclerosis. So in a trial, 17 people with remitting MS found that a modified fasting regimen induced changes reminiscent of those in rodent EAE models, which included the possible beneficial alterations to gut microbiota. Also, FMD may improve clinical and quality of life scores in people with relapsing remitting MS. So now we're going to talk about the common adverse effects of fasting. So individuals who maintained a medically supervised water-only fast for 2 or more days experienced effects that were mild to moderate and included fatigue, insomnia, nausea, headache, hypertension, which however was deemed incidental since 97% of people with hypertension saw it as an adverse effect, and since they had hypertension as their dominant medical complaint, pre-syncope or fainting, dyspepsia, back pain, and pain in the extremity. Period fasting was also associated with natural diuresis or natriuresis of fasting, which is basically where you lose large amounts of water and sodium in your urine. So fasting periods lasting 24 to 48 hours or longer. Natriuresis actually expose individuals to dehydration and low sodium levels, which, if left untreated, could produce symptoms such as fatigue, headache, and pre-syncope. However, this could be avoided by ensuring adequate water and salt intake. So individuals undergoing a prolonged fast have side effects such as edema, severe hypokalemia, bowel obstruction, urine nephrolithiasis, ventricular arrhythmias, and even death, if done wrong. Also, individuals doing water-only fasting for 2 or more days, none of these were side effects actually occurred. Now we're going to talk about the symptomatic and metabolic effects of fasting versus severe calorie restriction. Individuals doing short-term fasts report a lack of hunger that may be proportional to the level of ketosis achieved, as well as improvements in energy, mood, self-confidence, and quality of life. So, what are the symptoms of severe calorie restriction? Well, this includes persistent hunger, fatigue, irritability, apathy, and loss of sex drive. This may be based on how well your metabolic rate is resting, however. So the human body also adapts to chronic 20 to 40% reduction in calorie intake by lowering its resting metabolic rate to some degree. And so basically, whatever your calorie intake level might be, your metabolic rate is going to try to match that exact percentage. And so fasting also promotes a 5 to 15% increase in resting metabolic rate, which generally peaks 2 to 3 days after the initiation of a fasting period, and after which the metabolic rate lowers to more or less its original rate. Calorie restriction also reduces sympathetic activity, whereas fasting increases it via the activation of the counter-regulatory hormones such as GH, cortisol, and catecholamines. So now we're going to talk about muscle mass and exercise tolerance. So the degree of weight loss, including muscle loss, depends on the initial body fat, calorie, and protein intake, and exercise levels prior to when you're fasting. So with overweight and obese individuals, protein intakes of 0.8 and 1.2 grams per kilogram of body weight per day have sparing effects on lean mass. So with low and normal weight individuals, they display higher rates of protein oxidation relating to energy expenditure compared to obese individuals. So this basically suggests that leaner people may require more protein per kilogram of body weight to maintain muscle mass. Also, regular exercise is shown to prevent muscle loss in obese and normal weight individuals undergoing fasting regimens. So according to a 12-week study, obese individuals combined ADF with endurance exercise for 3 times per week, and as a result, they reduced their fat mass and retained lean mass in superior manner to either ADF or exercise alone. So now we're going to talk about fasting-induced insulin resistance. So fasting periods exceeding 48 hours in humans are accompanied by a decrease in skeletal muscle insulin sensitivity. With fasting-induced insulin resistance or starvation diabetes, this develops in the setting of hypoglycemia and hypoinsulinemia and probably serves to limit glucose uptake to skeletal muscle, ensuring that the steady glucose supply always remains available for obligatory requirements of the brain. So basically, this goes back to the whole switch metaphor. So when you're fasting, you're gonna need to save all your glucose. And so what happens here is that if your body's in a state of hypoglycemia and hypoinsulinemia, then that means that you're actually saving that glucose for your skeletal muscle, because let's pretend for a minute that the skeletal muscle is actually a building, and so when you exit the building, you turn the light off, and when you turn the light off, you're saving energy for that building, and so that's basically the same thing your body's doing when it's in a state of hypoinsulinemia and hypoglycemia in the fasting state. Then that basically means that you're saving all your glucose, so that way you can save it for your skeletal muscle, and not only for your skeletal muscle, but for the requirements of your brain also. So fasting-induced insulin resistance also represents a normal physiological adaptation to preserve brain function. So how does insulin resistance differ? Well, it develops in the setting of hyperglycemia and hypoinsulinemia. Since the latter is pathological, this may lead to type 2 diabetes. So now we're going to talk about compensatory overeating. So individuals may become susceptible to compensatory overeating, in which the effects would mitigate the beneficial effects of fasting. So for over a century, increased hunger has led to post-restriction hyperphagia, which has been documented in people subjected to severe calorie restriction. However, in recent studies on people who fasted, they did not show any signs of compensatory overeating on feeding days. Also, in recent studies, scientists found that an increase in calorie intake on feeding days did not equal an extra intake of calories to compensate for the overall calorie deficit induced by fasting periods. So now that we learned about fasting and neurological disease, let's talk about fasting in the lungs and how Ramadan intermittent fasting could possibly affect the lungs. Now we're going to talk about fasting in the lungs. And so this actually was a study that was published in 2017, and it was conducted by Aher Zuari, Imed Latiri, and Muhammad Muhab, who work at the Physiology Laboratory in the Department of Hospital Hygiene at the University of Saudi. So all three, including Imed Latiri, have studied the dietary needs of people during Ramadan and how their body reacts during their fasting regimen. Ramadan, so this was actually published under the name The Effects of Ramadan Intermittent Fasting, or RIF, on Stable COPD Patients. And so this study was meant to assess the effects of RIF on spirometric data measured in male patients with stable COPD, and this involved 16 male patients. This study was also split into 3 sessions: before R, end of R, and after R. And for each of those sessions, they were selected for spirometry tests that were consistently performed for 2.5 to 4.5 hours before breaking the fast. And so when people think of Ramadan, they think of it as only abstaining from food. But as a matter of fact, you also abstain from smoking, medication, and sexual intercourse. And so basically during the study, medications were given via oral and parenteral route, but not all drugs were used via inhalation route. And so the restoration actually depends on the geographical area, season and country, the end of spring, the beginning of summer, the tropics, and temperate locations being longer. And also, the one thing to remember about this is that Ramadan usually lasts to about 12 to 14 hours, but it can last up to 18 or 22 hours in summer in extreme latitude areas. And so there are some people that are excluded from Ramadan fasting, such as prepubescent children, elderly, travelers, menstruating, pregnant, and breastfeeding women, and patients who have disease conditions are also exempted. However, some do not accept these restrictions, and they actually prefer fasting during Ramadan. And so, about 67% of Muslim asthmatics do not consider asthma to be a drawback to fasting. And so basically the way they do it is that if you're on a medication of some sort, then they actually rearrange your medication times to iftar and suhoor, or iftar being sunset and suhoor being sunrise, and so that way they can still participate in the fast. About 3% of Muslim patients with lung cancer and 93% of Turkish chronic obstructive pulmonary disease, or COPD, patients are Ramadan fasters. So, recent international guidelines actually suggest the orderly use of symptom-relieving treatment as well as disease development prevention, such as monitoring and education of patients, as well as the avoidance of risk factors. And so, basically what this means is that before doing a study like this, you just gotta let them know that, like, what you're gonna be doing, and you have to suggest some symptom-relieving treatment to them in the event something does happen, and you also can teach them about disease development prevention. And so basically those are just the international guidelines for about what you should do to prepare your subjects for a study. And so the effects of religious beliefs and behaviors haven't been addressed, and no recommendations have been advanced for COPD patients who prefer fasting during Ramadan. So by the religious beliefs and behaviors, so there are going to be some religions out there that may be more lenient towards medicine, whereas there may be more religions that may be more that may be a little bit more strict with medicine, or maybe they don't really like doing any medicine at all. And so basically, every religion is going to be different, when it comes to this. So I'm not really sure what Islam's opinion is when it comes to medicine. But I know some religions, some are going to be more lenient and some are going to be more strict. And so during the month of Ramadan, spirometric tests continue to be normally performed on patients with COPD who want to fast. Also, the studies examining lung function with RIF are scarce, including those with only healthy adults or asthmatic patients, and even if those are presented, they have discrepancies in their findings. Basically that's why there isn't a lot of studies out there involving the RIF and lung function, because again, there may be only studies that involve healthy adults or asthmatic adults, and even with these studies, some of these findings can have some discrepancies in them. And so for this study, scientists actually hypothesized that RIF did not bring any significant changes in spirometric values of patients with stable COPD. So, study performed during 2016 showed an elapsed time from dawn to sunset, and was about 16.5 hours during the whole month of Ramadan, which is from June 6th to July 5th, and the ambient temp and humidity, and meant the standard deviation, or SD, was actually during a 50-day study period. And so they used 15 male patients ages 40 to 80 years. And so before this study even happened, the folders and files of COPD patients filed in the above two departments were verified. And then second, some patients were directly addressed by two pulmonologists for basic help group of SAUSI, and a letter of information containing details about the study and visit dates were given to patients. And so there's also a non-inclusion criteria that was involved in this. So a non-inclusion criteria is basically a list of criteria to where a person can't participate in a study. And so in the case of intermittent fast RIF, a person could not participate if they had a history of RIF less than 20 years, nargile use, actual cigarette smoking history less than 10 pack years, tobacco cessation less than 6 months, non-COPD patient, neuromuscular disease, diabetes mellitus, congestive heart failure, malignancy, vertebral column or foramen cage abnormalities, oral corticosteroid treatment, and lack of cooperation during the spirometry test. And so patients were also instructed to avoid using short-acting bronchodilators 6 to 8 hours prior to the spirometry test. and to avoid any confounding effects, patients with an unstable respiratory state within 4 weeks prior to the spirometry test were excluded. And so basically, for patients who had who had very, very problematic breathing problems, then they were actually excluded from the study. So also during these free sessions, they were also divided into separate days. So for the before Ramadan session, it was 5 days. For the end of Ramadan, it was 3 days. And after Ramadan, it was 14 days. So during the before our session, patients had to answer a medical questionnaire. And basically, all scientists did was that they recorded anthropometric data that was measured and or noted, and the spirometry test was performed. On the second and third sessions, anthropometric and spirometric data were determined. Patients were also given a questionnaire on if they fasted on Ramadan, and if they did, they were asked about socioeconomic and schooling levels, personal medical or surgical histories, and chronic medication use, dyspnea, and smoking. There's also a non-validated questionnaire which was used to assess the subject characteristics, or by their characteristics they meant their health history. And so this included the patient's history of their COPD exacerbation, which included hospitalizations that were recorded. So patients were also asked about their bronchodilator use, their latest meal, and sleep duration. So you're probably wondering why would they ask about their meal and sleep duration? Well, the meal duration would be the time and the hours between their last meal and the spirometry test, and the sleep duration would be the time and hours of sleeping, including night sleep and naps, before the spirometry tests were noted. Also, scientists looked at cigarette smoking and pack years and Neuronal use with the patients. So spirometric tests were also performed at the same time of the day, between 1500 hours and 1700 hours approximately, which would be 279 to 150 minutes before iftar, which would mean fasting hours would be 16 to 59 hours if it was carried out in a standing position. Also for the peak expiratory flow, PEF, and L/S and FEV1 and FVC ratio would be the absolute value if they were expressed in absolute values at body temperature, barometric pressure saturated with water vapor. Also, the metric spirometric data was also expressed as percentages of predicted local reference values. So there's also a reversibility test that was largely described elsewhere that was performed during the before our session. And so a reversibility test is just basically used to see how well your lungs are functioning. So the severity of airflow limitation was based on postbronchial dilator FEV1. It was classified as mild, moderate, severe, and very severe. And so they also put this in the ABCD assessment tool derived from patients' symptoms and their exacerbation history, which included prior hospitalizations, and was applied in 4 groups. A, B, C, and D were categorized. So A, B, C, and D were basically the same as mild, moderate, severe, and very severe. So now we're going to be looking at the statistical analysis. So the analysis of variable distribution was performed during the Kolmogorov-Smirnov test. And in case for everybody that doesn't know what that is, the Kolmogorov-Smirnov test is a non-parametric test of the equality of continuous one-dimensional probability distributions that can be used to compare a sample with a reference probability distribution, or to compare 2 samples. So basically what they're doing is that they're comparing these samples, the samples of the test, they're comparing these 2 samples here with a probability distribution. And so when a distribution was normal and variances were equal, the results were expressed as a mean SD, or a 95% confidence interval. Also, the results were expressed by their medians, or lower and upper quartiles. Comparisons of the anthropometric and spirometric data, sleep and meal durations, and time of last use of bronchodilator were made between 3 sessions, before R, end of R, and after R. The results were obtained by applying the repeated measures of analysis of variance. There's also a significant difference between means that were tested using a Tukey post hoc test, and the Tukey post hoc test would is actually a single-step multiple comparison procedure and statistical analysis. So what they're doing is that with this 2 post hoc test, they wanted to test the means. They wanted to see the difference between the means that were tested using the 2 post hoc test, and so basically the way they did this was that they wanted to do a comparison procedure to see how those differences compared, and they wanted to do it basically a statistical analysis on it as well. And so another thing to know about the 2 post hoc test is it can be used on raw data or in conjunction with an ANOVA to find means that are significantly different from each other. So basically, after the comparison of the results, there's actually a significance set at the 0.05 level. So now we are going to talk about the results of this study. So among the 25 examined patients, only 16 COPD patients completed the free sessions. So there were a couple of reasons for dropout. So one would have been post-bronchial dilator issues, and then there was absence between the second and third sessions. So only one COPD patient wasn't under respiratory treatment. 12, 14, and 6 patients were treated by bronchodilators, inhaled corticoid, and anticholinergic. 7 COPD patients were MMRC, 4 had cardiovascular diseases, 2 had stable hypertension, 1 had obliterating arteriopathy of the lower limbs, and 1 had dilated cardiomyopathy. Also, 2 were anemic, and 1 had hypothyroid, and 1 had dyslipidemia. So airflow limitation was qualified as mild to moderate and severe to very severe in 7 and 9 patients. Also, the mean SD of the post-bronchial dilator test was FEB1/FBC, FEV, and FBC, and those results were 0.52, 0.14%, 48 to 19%, and 77 to 16%. And so about 8, 6, and 2 patients belonged to groups A, B, and D. Remember, A, B, and D were mild, moderate to severe. And so the mean SD, which was 95% confidence interval of age and height, were 63.63 and 7.19. And then, which would actually be 59.80 to 67.46 years, and 172 to 5 would actually represent 169 to 174 centimeters in the spirometry test. Also, 12, 3, and 1 patient were normal weight, overweight, and obese. Your ambient temperature was significantly higher during the end of R session compared to the before R1, and your humidity was significantly lower during the after R session compared to the before R1. And so, remember at the beginning of this, scientists hypothesized that rest wouldn't affect any lung function? Well, let's look at the main conclusions they came up with. And so the first conclusion they came up with was that rest had no significant effect on weight or BMI. The second was that there was no difference between the free session sleep duration, and C, there was a significant difference between the free session meal duration, which would mostly be at the end of our meal duration, which was significantly higher than those of before and after our sessions. So basically, let's look this up real quick. And so what they're saying right now is that so far there's no significant weight loss or BMI. There's no changes in that. And also, there's no difference between the free session sleep duration, because remember, just like depending on your sleep duration, your meal duration, this was going to affect your results. And then however, there was a significant difference between the free session meal duration. And so it turned out that the end of our meal duration was significantly higher than those of before and after our sessions, because obviously it would be higher because they just went through Ramadan intermittent fast, so they would probably be pretty hungry by now. And so those are the conclusions they came up with. So the overall main finding was that their hypothesis was actually right, since RIF did not bring any changes in spirometric data. Also, the effect of RIF on the respiratory system is neither a sample academic issue, nor is it of awareness only just in Muslim countries, because as you can see, there are still many other countries that are studying fasting. So, available proof concerning the health benefits of RIF is limited and controversial. However, they do exist. They just aren't shown as much because, again, they're very limited because of that. Because there's not that much funding for it, and some of it is considered controversial. Also, there has been no previous study that has debated the effects of RIF on lung function data of COPD patients. However, there are some studies that have examined the impacts of RIF on respiratory mechanics of both healthy and asthmatic adults. The RIF record of patients could actually influence respiratory adaptations. So, if you were like an experienced faster, then your respiratory system could actually adapt to that. And it's not considered in related studies, including healthy and asthmatic patients. Also, all COPD patients were ex-smokers. So, and the reason why the scientists kept checking over and over again if a patient had smoked before or if they had any nargile use was because it turns out that smokers, compared with ex-smokers, are more irritable during Ramadan. And so, oral medications, injections, ear and nose drops, and suppositories were not allowed for patients who preferred fasting. However, there was the use of eye drops and inhalers that were accepted as a process that does not influence fasting. There is also a considerable amount of COPD patients that adjusted their medication regimens during RIF without asking their physicians. For example, in a Turkish study, a majority of Muslim COPD patients actually quit using their medications during Ramadan. Also, in a present study, patients asked about either to keep using their habitual medication or to adjust it in suhoor and iftar times. So, only short-acting bronchodilators were stopped 6 to 8 hours before the spirometry test. Also, all inhaled medications used at iftar and suhoor times are not expected to decrease the efficacy of the drugs, and this method seems to be suitable for patients who do not want to use their drugs throughout fasting hours. And so, basically, just to summarize all this up, it is common for asthmatic patients who are celebrating Ramadan to either adjust their medications or not even take any of their medications at all. And so it is common. And so what this study showed was that this method seemed to be suitable for patients who did not want to use their drugs throughout their fasting hours. And so by that they mean that the whole adjustment schedule seemed suitable for them. So patients were aware of the study aims. However, this might have increased concern about spiritual prejudice, and then it might have stimulated fasters to make additional efforts in lung function testing. So like I said before, with every religion, there's going to have different views on medicine. Some may be a little bit more lenient when it comes to medicine and medical testing. Others may not be so lenient. So it all depends on the type of religion you come from. And so the second limitation was that the non-inclusion of a control group of non-fasting COPD patients might be a limitation because the internal power of results from these studies and changes in variables assessed cannot be attributed exclusively to risk. And so recruiting non-fasting groups in Muslim countries is not effortless due to religious attitudes. And so basically, it's just like some of the results from these studies and the changes in variables they can't tell for sure exactly if these are actually from REF or not. But that's why they did this test to see if it was or if it wasn't. Also, patients with asthma, they did in COPD, they do not feel their diseases to be an inhibitory factor to fast at Ramadan. Also, on 12 studies on lung function data of healthy and or asthmatic adults, so there are 12 studies that were supposed to be performed on this. Only 2 performed in India and Iran. So scientists also wanted to evaluate the hydration status and diet regimen, especially in those who took herbal medicines and used supplements. And the reason they did this was because they wanted to see if any of the patients had hypohydration. And so hypohydration causes a considerable raise in respiratory flow rates because of the loss of water from the bronchiovascular shaft. The airway mucosa potentially reduce the airway resistance. So Because of that loss of water, that loss of water from the bronchiovascular shaft, it may have actually helped to reduce the airway resistance in their lungs. Also, dietary abnormalities. Scientists wanted to see how this negatively influenced the lung structure and function, how it influenced the neural control of breathing and the functioning of respiratory muscles. They also wanted to assess the impact of RIF on respiratory symptoms, or the COPD patient's physical activity status, or the static volumes, which are very useful in COPD management. So RIF did not influence the weight of stable COPD patients, and it was also unlikely that in the present study, patients were dehydrated. And so with asthmatic patients, only one study looked into the weight changes, and they were actually lower at the end of R compared to before R. And so during a systematic review, they found that RIF could result in a significant weight loss of 1.24 kilograms. The effects of RIF on weight could be due to a patient's physical activity levels. There's also no significant effect of RIF on spirometry data of stable COPD patients. Some studies also state that RIF had no effect on spirometric data, while others state it impacted some of them. Also, some studies, asthmatic patients can tolerate RIF without significant alteration of spirometric flows. There is also a significant increase in PEF by an average of 17% during the end of R session compared to the before R one. The mean PEF variability actually decreased from 13 to 10% in the first and fourth weeks of Ramadan. Some studies also reported that RIF affects the clinical symptoms of asthma and the frequency of hospitalizations. Others state that reduced wheezing after RIF was also discovered. Fasting might also be an important determining factor in medication compliance by modifying drug use behaviors in COPD and asthmatic patients. So basically, like by a determining factor in medication compliance, it means that basically you're still on your medication during this whole thing, like during the study, but they modified it. So that's why they said it may have had an important determining factor in how they handled their medication compliance. Now we're going to be looking at how can changes in lung function data during RIF be explained. So scientists have actually hypothesized that the hydration status of COPD patients was not disturbed, and insignificant changes in weight may have some physiological impact on preserving spirometric data during RIF. So somehow throughout this study, there may have been like some kind of physiological process the body may have went through to maintain a little bit of weight and to keep the hydration going in the lungs. And so now that we talked about this, let's talk about animals, and specifically those located in the Arctic, and how we can compare their bodies during a fast with ours. So now we're going to talk about fasting, the creature habit, in which we look at animals who specifically live in Arctic environments and how they cope with the long-term food deprivation. And so this study was conducted by Castellini M.A. and Bria L.D., who both worked at the Institute of Marine Science at the University of Alaska. They have done numerous studies on animals in both their physical and physiological environments. And this study was conducted in 1992, and it's under the name The Biochemistry of Natural Fasting at Its Limits. So according to their study, several groups of animals are adopted for extremely long duration of fasting as part of their reproductive cycle. And so basically, it just like have you ever seen those documentaries where there's a polar bear trying to catch a seal and it misses a seal, and then the narrator says, "Oh no, now this polar bear has to go an X amount of months without food." And so basically that's what it's talking about here, is that the polar bear's body is actually adapted to fasting. And so for penguins, bears, and seals, fasting routinely without food or water for months at a time is pretty common. And the thing about this is that even though they're fasting, they do not starve to death. They do not starve. Also, distinct biochemical adaptations in lipid, carbohydrate, and protein metabolism allow animals to survive. So for penguins and seals, a fast may be limited by the changes that occur in biochemical regulation near the end of the fast. Also, some fasting periods happen due to a lack of food or because it is part of the natural history of the species. So, for example, the marmot can fast up to 3 weeks in winter when the food is lacking, and a northern elephant seal can last up to 90 days as part of its reproductive cycle. And so basically, these animals are pretty familiar with fasting when it comes to a very long time without food deprivation, and it could be because A, there's a lack of food, or B, just because of their natural history as a species. Now we're going to talk about fasting versus starving. So a fasting animal is actually adapted to maintain a level of metabolic homeostasis so that critical organ function is maintained. So the homeostasis, as we all learned, is basically where our body tries to find its equilibrium or its inner equilibrium or its balance. And so when you're fasting, your body is going to try to find that equilibrium, and so it's going to try to learn how to take care of itself without food for a little bit, and so that's when it goes into homeostasis. And because it's in homeostasis, that's when organ function is protected. And so, however, if an animal actually starts to reach starvation mode, then that's actually the state in which homeostatic control is lost and critical, and organ function becomes completely compromised. And one thing to remember is that an animal may starve to death if deprived of food, but an animal that naturally fasts will not fast to death. So let's say, for example, if an animal was on a fasting regimen, like the polar bear, for example, but then its body was telling him to eat again, and he finds that seal. Okay, so the polar bear goes and tries to run after that seal, but again that seal jumps into the water, and so basically, if that seal jumps into the water and is freed, that means the polar bear is being deprived of food. And so that's when he'll start. And so basically, that's when he'll start starving if that food is deprived from him for long enough. So now we're going to talk about non-fasting adapted species, phase 1. Some humans can survive for 12 months without food. So during phase 1, the first days of food deprivation, the hepatic glycogen reserves are almost completely utilized as the body defends circulating glucose levels. So basically, your body knows it's going to be going into a fasting mode eventually. So what it does is that it's going to be utilizing as much glucose as it can, and it's also going to be saving some, because it knows that once it starts going to fasting mode, that glucose is no longer going to be available for it to use, and it's going to have to live on its fat reserves. And so the thing about this is that your body's going to be having a circulating concentration of glucose but it's going to be tightly regulated, and it's because it's going to be very important for the central nervous system or the CNS to have that glucose as soon as you're done with your fast. And so also during phase 1, stored lipids are activated as the body switches to fat oxidation and reduces protein catabolism. So also at this point, your lipids are activated and your body starts to switch to fat oxidation. And metabolic rate also begins to decline at this point. And in humans, this can fall to less than 50% of the non-fasting rate. So now we're on phase 2. So during phase 2, there's an increased oxidation of lipids, there's an increased production of ketone bodies, and there's a partial sparing of proteins. Increased lipids are important at this moment because they're able to provide metabolized energy for the body. Also, CNS fuel is not changed during fasting, and the body has presumably depleted its circulating glucose supply. Also, the thing about this is that the lipids cannot cross the blood-brain barrier, but ketone bodies, a product of lipid catabolism, can cross the barrier and act as a fuel source for the brain. And so basically here, just like if you're like, let's pretend the blood-brain barrier is kind of like some kind of club you want to get into. Okay, so pretend you're a lipid. So unfortunately, if you're like a whole lipid, then you can't really get into the blood-brain barrier. However, if you're a ketone body, then you can get in because you're actually a product of lipid catabolism, or breaking down a lipid into a simpler molecule. And so if you break down a lipid into a simpler molecule, the blood-brain barrier will be able to accept that, and you can just cross right over and act as a fuel source to the brain. But again, if you're a lipid and you're just a lipid, then you won't be able to cross over. Also, for non-fasting species, both circulating lipids as non-esterified fatty acids, or NEFA, and ketone bodies increase in the concentration of in the blood. Also, a high production of ketone bodies also alters acid-base balance in a state of metabolic acidosis or ketosis, which may develop. So now we're continuing phase 2, and so at this point, protein degradation to amino acids provides precursors for gluconeogenic production of glucose. Also during phase 2, ketones from lipid utilization and glucose derived from protein provide energy for the CNS, while oxidation of fat provides energy for the remainder of the body. Protein catabolism is also decreased during fasting. However, that does not mean that it actually stops. The body may have enough lipids to burn, but protein from the skeletal muscle will become limited. So for the cardiac muscle, it's actually the first source of protein that the body will go to catabolize protein to amino acids in order to supply CNS fuel via gluconeogenesis. And so a person who has a high fat index can die due to protein wasting in the cardiac tissue. So if a person has like a high fat index, then the body can actually eat all that muscle up, and it could actually be pretty life-threatening, since it's eating all your muscle up, then it's actually going to cause like muscle wasting basically. And so unfortunately, the body does not recognize the excessive loss of protein, and there is no signal to end it. And so unfortunately, if the body keeps on eating that high fat index, then it's basically gonna eat up all your muscle, and the body's not going to even be able to know that it's losing a lot of protein, and that can end up to possibly possibly being a life-threatening situation. And so that's why earlier in the earlier slide we talked about exercise, because during exercise you're actually growing new muscle. And so if you're growing new muscle, that means that your body still have some muscle to work with to get some protein. So that's why it's very important to exercise, because the thing is that if you don't exercise during a fast, then basically you could head on to starvation. And another thing is that during these fasts, people apparently tried some fad diets. And so there was actually some people that apparently got some liquid protein supplements, and these supplements were promoted to be seen as an energy source during long fast. But the problem was that the protein was not of the correct nature to provide amino acids for gluconeogenesis. And so the result was that the cardiac muscle still wasted, and there was a significant number of people that died on these liquid protein diets. And so the best thing to do would probably be to stay away from anything that you see on TV. Like if you see like any liquid protein supplements that are being promoted on TV, saying, hey, this can give you an X amount of energy during your fast, and you definitely gotta be careful with those. And so now we're going to talk about stage 3, terminal starvation. So now we're on to stage 3, which is terminal starvation. So this is basically the part where everybody worries about, and it is something to worry about if you feel like you're going to start heading there. And so about 30 to 50% of body protein has been wasted at this point. And not only that, but lipid utilization falls, circulating ketones decline, and the subject is in serious risk of starving to death. Other organs are also compromised, such as the kidney, since they'll be at risk of renal failure due to the accumulation of uric acid. Repeating could possibly take up to a year, and if this happens, this could possibly have to be done under medical supervision. And then, however, there's a possible solution, and the best solution to avoid this is to prolong phase 2, because this will actually spare the body protein as long as possible to end the fast before phase 3. And so what you want to do is that you want to stay in phase 2 for as long as you can, because if you're still in phase 2, you're still giving enough protein for the body to spare. So this pathway is actually used by species such as penguins, bears, and seals. And so now that we've talked about animals and how they fast and how this can compare to humans, let's talk about fasting and the herpes virus. So now we're going to be talking about fasting, the herpes virus, and cancer. So basically, this article is going to go over how fasting could possibly treat the herpes virus, especially in those who have cancer. So this study was done by Shinichi Esaki, Samuel D. Rabkin, and Robert L. Masherza, who all work at the Department of Neurosurgery at the Massachusetts General Hospital at Harvard Medical School. All three have done studies in which they looked at the connection between the herpes virus and cancer, including glioblastoma. And so this study was published in 2016 under the name Transient Fasting Enhances Replication of Oncolytic Herpes Simplex Virus in Glioblastoma. So basically, according to the study, short-term nutritional restriction or fasting is shown to enhance the efficacy of chemotherapy by sensitizing cancer cells and protecting normal cells in a variety of cancer models, including glioblastoma and GBM. So basically, what scientists are saying is that by fasting, there could be a possibility that your body could be able to distinguish by itself which cells need to go and which cells can stay. And so basically that's going to be the point of the study here. And so scientists also hypothesized that fasting would increase the replication of the oncolytic herpes simplex virus, or the OHSV, in GBM. So what they did was that they took patient-derived GBM cell lines, and they were fasted from their growth in glucose and fetal calf serum in a restricted cultural medium. So basically what they did was that they took them out of their cultural medium, so they took the GBM cells and they basically took them away from basically any sugar-related models such as fetal calf serum and glucose, and they performed a study to see how fasting could actually destroy this virus. So during this study, patients were required to undergo a transient fast. So a transient fast is a 24-hour fasting regimen followed by a 24-hour recovery regimen in a complete medium. And what happened was that in a complete medium, this actually increased the late virus gene expression in G47 yields about twofold, and as a result, enhanced G47 killing of GBM cells. So basically what happened was that with this transient fasting, this actually activated the late virus gene, also known as the G47, and what happened was that this actually helps increase its yields by a twofold, and as a result, this actually enhanced the killing of the GBM cells. So just think of the GBM cells as a monster who basically have a monster inside of them. So the GBM cells like a really powerful monster, but it can actually destroy an entire city or the entire body. But the thing is that with fasting, you're actually igniting the monster's inner kryptonite, or the G47, and so when you ignite that kryptonite, then that means that you're actually enhancing the kryptonite's ability to kill that monster. And so Not only that, but transient fasting also suppressed the phosphorylation of subunit of eukaryotic initiation factor 2A, ELF2A, and CJON and terminal kinases, J and K in GBM cells, not in astrocytes. So it's not in human astrocytes, but these were found in GBM cells. And so basically, this is just a fancy way of saying that that not only did the fasting release the G47, but it also helped release the 2A, ELF2A, and C-jun terminal kinases, or J and K, in order to help the G47 destroy the monster or GBM cell even more. There is also a pharmacological inhibition of J and K that increased the G47 yield. So also during transient fasting, which was also a 48-hour food restriction and 24-hour recovery time, it actually doubled the luciferase activity after they injected an intratumoral G47 US11 fluid injection into orthotopic GBM xenograft. So basically what they did was that they injected this intratumoral fluid inside the GBM. And what happened was that there's also this double luciferase effect, so that way, not only were you like killing the GBM, but there's a possibility that you're also killing the cancer. Also, transient fasting also increases G47 replication and oncolytic activity in human GBM cells. So the results of the study state that transient fasting may be effectively combined to enhance oncolytic HSV therapy of GBM. So what you're saying here is that there could be a possibility that transient fasting could actually be used in the near future in order to combat the HSV virus in cancer patients. So treatments such as surgical resection, radiotherapy, and chemotherapy have not improved survival rates for patients with a median of 14.6 months. So dietary restrictions, according to scientists, they state that dietary restrictions enhances the protection of organisms. So also with nutrient signaling pathways, they are actually suppressed, and this also includes the insulin-like growth factor, IGFI, which is a receptor pathway as shown in fasted humans. So with this nutrient signaling pathways are suppressed because, as we know, they're not being the body's not being fed during all this, and so that's why there's no nutrient signaling pathways going on here. And so this also includes an insulin-like growth factor IGFI receptor pathway. And remember, we talked about that a little bit a while back, but that can actually influence your insulin levels. And so short-term exposure to a severely restricted diet in a fasting regimen has shown to enhance the efficacy of chemotherapy by sensitizing tumor cells and protecting normal cells in a variety of cancer models, including GBM. So basically what's happening here is that when you're fasting, you're actually letting your body decide which cells are dangerous and which cells are not. And so also fasting, not only are you letting your body decide which ones to get rid of, but you're also helping to sensitize those tumor cells. And so by sensitize, you're actually giving your body's actually giving them less power and stuff. So that's what it means by sensitizing. In one case series report, 10 patients with different cancers were safely fasted for 48 hours prior and/or following chemotherapy, with various drugs warranting randomized clinical trials to determine the effect of fasting in combination with chemotherapy. So, in a pilot study evaluating KD, the trend for longer progression-free survival was seen more in the group who had actually accomplished stable ketosis through a ketogenic diet compared to the group who didn't have a ketogenic diet. So there have also been several clinical trials that are currently ongoing to assess if short-term fasting or low-calorie diet in combination with chemotherapy reduces the adverse effects and increases anti-tumor effects in different types of cancers. And so what happens is that fasting actually downregulates the proliferation of associated genes in normal tissue. So basically, what happens is that in normal non-cancerous tissues, fasting actually downregulates the proliferation associated genes that are associated with cancer. So in a way, so it's actually downregulating those cancer replicating genes, but it actually upregulates or does not alter them in breast cancer allografts. And so basically, it just like just like they're being altered in normal tissues, but at the same time, it also doesn't really affect the tissue in the breast cancer allografts. So also fasting also protects normal cells by reallocating energy from reproduction and growth processes to maintenance pathways. So instead of like focusing on basically reproduction and growth, it's actually focusing on maintenance pathways, or how normal cells can maintain themselves in order to protect themselves from like dangerous cancer cells. Cancer cells also respond to fasting by promoting oncogenic signaling and protein synthesis. So differential stress resistance. This is actually the basis for fasting-induced selective sensitization of cancer cells to cytotoxic anti-cancer agents. And so basically, the differential stress resistance, all of this is just another basis for the body to target the bad cells from the good cells. And so, ensuring virus mRNA translation is critical for progeny production, since HSV has no virus gene encoding protein synthesis apparatus, which is dependent on the machinery of the host cell. So basically, with the HSV virus, this virus doesn't really have like a virus gene that can encode protein synthesis apparatus. So the only way it can literally replicate itself is if it hooks on to another host cell. So it's basically like the physiological game of fishing. So if that hook catches a fish or a cell, then basically it has that cell. But fasting, you can actually but in fasting, you can actually again differentiate. Your body will be able to differentiate which ones are the bad cells and which ones are the good cells before any of those good cells become host cells for the HSV virus. And so also, all OHSVs have been tested clinically for GBM and have deletions of Y34.5, which is a key gene to sustain protein synthesis by counteracting the host double-stranded RNA-dependent protein kinase (PKR) mediated phosphorylation of eukaryotic initiation factor 2A ELS2A. And so basically all this is saying also is that basically with that deleted gene, there's actually more of an opportunity to get that 2A gene going, so that way it can help fight the cancer cells more. So also with HSV mutants, they may be susceptible to host anti-HSV defense mechanisms, leading to a compromised virus replication and efficacy. Also, an inaberrantly active oncogenic signaling, such as the ROS pathway in cancer, can enhance OHSV replication and cancer selectivity. Now we're going to be looking at fasting and the coronavirus. So this was an article that was written by Dr. Talis Barker, and he's actually a water fasting coach and has been doing programs for many years. He is a contributor for waterfasting.org and has written numerous articles about fasting in general. He also instructs various programs as well to help people introduce themselves to the practice of water fasting. And so this was actually published recently in 2020, as you can see, and it's under the title the article is under the title Fasting Against Coronavirus or COVID-19 and How to Boost Immunity and Maximize Health. So the first thing we're going to look at is why fasting is your best bet against coronavirus. So even though improvement in exercise can make changes, this could probably take about months or even years to boost the immune system to the extent of having a better chance of fighting off an illness. However, there are shorter-term strategies, such as taking health supplements and vitamin C and echinacea. and other herbal remedies. So even though this can support the immune system in functioning, this doesn't necessarily mean it improves the structure of the countless individual elements which comprise the immune system itself. So the only way structural improvements of the immune system can happen is during and after a fast. So let's take a look at the time of Hippocrates, for example. So during his time, he actually applied fast to treat all fevers and acute diseases. Also during the Middle Ages, he actually used fasting to fight the bubonic plague. And so we also have Dr. Herbert Shelton, who is known as the father of modern fasting, and he's actually cured typhoid, pneumonia, dysentery, and other infectious diseases through fasting. And so basically, Dr. Baker has actually coached hundreds of fasting clients to improve the symptoms of or fully heal from conditions as diverse as asthma, cancer, chronic fatigue syndrome, CFS, colitis, eczema, fibroids, fibromyalgia, food allergies, hypothyroidism, IBS, multiple sclerosis, or MS, musculoskeletal trauma, and tumors. And even, for example, fasting is even used in Western medicine, which can help with the efficacy of chemotherapy. And also not only that, but it can actually help prevent and heal disease as well. So, what are the key points to consider when fasting to prevent illness? Well, according to Dr. Barker, he states to undertake the longest fast you can comfortably and conveniently manage. So, he also states that it is best to fast when in maximum health because this actually helps the body to devote its greatest energy to boosting the immune system rather than fighting off a pre-existing condition or illness. He also states that it is best to fast in the period immediately before you expect to be exposed to an infectious pathogen. So in the case of COVID-19, that means now or as soon as possible, especially for those living in Europe or the US. So he also states that fasting boosts the immune system, and so because of this, the effects are actually the strongest at the end of the fast and in the period immediately afterwards. He also states that the longer the fast, the longer the honeymoon period will last. He also states that you want to be exposed in the period following the fast when the body has finished rebuilding itself and the immune system is still working at peak capacity. So, in the 7 to 10 days after the fast, or a week or two after breaking the fast, this may provide added protection for many weeks or months. So, an example would be a water fast in the early winter would actually boost the immune system for any infection encountered for the rest of the winter. The author himself also takes another 7 to 10 days of fast in the late spring or summer. So, also a fast could provide additional body memory of getting into deep ketosis, or our fat-burning metabolism, which enables quicker and easier access to detox. So, also according to Dr. Barker, he states that a spring fast would be less maintenance cleansing to do during a winter fast. So the body can focus on boosting the immune system. So basically what he's saying is that with a spring fast, it'll probably be less maintenance cleansing for the body than a winter fast would be. So what is Dr. Barker's first time advice for what is Dr. Barker's comparison of a first-time faster versus an experienced faster? Well, an experienced faster would more likely approach a 7 to 10 day winter fast from a stronger baseline level of health with a lower toxic load. Well, what would his first time advice be for a first time faster? So he suggests for a first time faster that they should try a 36-hour fast a few days or a week before trying a longer fast, which is easy since it's easier to start a 7 to 10 day fast. Also, he states that a 3 to 5 day fast offers a degree of increased protection, but it won't be as strong or last as long. So the ideal scenario would be to boost the MI against infection. So the best way to do this would be to do a 21-day fast in the period before you expect to be exposed, since the body needs 21 days to reach maximum potential for cleaning and healing. He also states that with 21 days of fasting, you're actually going to be cleaning out a majority of toxins from your body. However, you could feel weakness during your fast, this will help the body move emphasis from the surface of the body, including the muscles, to strengthening the inner works of the body, which would include the immune system. So now we're going to be talking about how to fast in order to treat illness. So for healthy people, it is best to fast as soon as possible in such cases. So basically, think of it like this. When animals get sick, they actually take a break from eating because they know that their body is saying that it needs time to heal by itself. So basically, as we've seen before in the previous slides, that's basically what our bodies are saying to ourselves too. And so what the author did was that he fasted when he got a cold or a flu. However, the symptoms would be rather different. They would range because either the bug would clear up within a day or two. However, there'll be other times where the symptoms will worsen before they got better. So again, I believe this depends on how much toxins you have in your body. So if you have a lower toxin level, then it's more likely that you might heal faster. But if you have more of a toxic level, then your symptoms may worsen before they get better. So I think it depends on the person and their toxin levels for that to happen. So also starting a fast upon the onset of symptoms results in regaining health after 2 or 3 days, even in the case of the flu. So also a heavy toxin load in a pathogen. So with a heavy toxin load and a pathogen in your body, you're actually fighting a war on both fronts. So prior to fasting, facing a pathogen with an immune system in good condition is your best bet to get rid of that pathogen. So fighting a war on 2 fronts while fasting he states is actually better than fighting a pathogen alone while eating, since it's actually due to an increased power of the immune system while fasting. So now that we talked about the coronavirus and fasting, let's talk about a famous author that that everybody may have heard of, and that's Upton Sinclair. So now we're going to be talking about Upton Sinclair and how he got rid of his ailments through fasting. So for those of you that don't know Upton Sinclair was an American author who's famous for his 1906 novel The Jungle, which discussed the issues on the meatpacking industry during his time. So some of his books were based on real life, such as Springtime and Harvest. Others were based on politics or autobiographies. And so basically what we're going to be talking about here, this is actually based on his autobiography called The Fasting Cure. And basically what this book is about him trying to find a way to treat his ailments because they're actually getting in the way of his quality of life. And so, according to the book, Sinclair grew up in a family who promoted healthy eating. And so basically, Sinclair's family was basically the kind of family that promoted healthy eating. Like they'll say, kids, eat your vegetables, eat healthy, stay away from junk food, and all that. But as Upton got older, he actually started to spend his life around quality food when he was living in New York. And he actually thought it was necessary to have that kind of food. So basically, Upton went through what we all went through, or what we all are currently going through when we grow up. Because when we grow up, we're moving out of our parents' house, and we're actually experiencing new things and stuff. And when we start to have new experiences, we start to get rid of the old of the teachings of our parents a little bit. So in a way, Upton's experiences actually kind of got him away from the teachings his parents taught him. And so basically because of the quality food that he was eating, he actually developed dyspepsia as an adult. And so he ended up getting some medicine and he would feel better. However, this would only be for about a year or two. And so eventually he actually found out that the food he consumed was not being eliminated from his system regularly. And so he actually found this kind of strange because he never drank any tea, he never had coffee, he never smoked he never had any alcohol, and he never smoked. However, he did work under a lot of pressure, and he did eat irregularly, and then he had a lot of unwholesome foods. And so this actually started to get to the point where he actually started having headaches, and he was very sensitive to colds. So during the summer months, Sinclair couldn't sleep well, and he had to drop work a lot because he was like so he was so tired, and he was just so sick that he just couldn't work anymore. And so he actually also had a nerve in his tooth that also died, and he had to wait for 3 days for pain to localize, and then he had the tooth drilled out. And then not only did he get really tired, but this also happened for a week or two, and then a week became a month, and then a month became several months. And so he also ended up getting sick for a week, and so this included chills, fever, nausea, and headaches. And not only him, but his family got sick also. So his little boy actually had pneumonia, and one winter he also had whooping cough in the summer. And so basically, well, at this point, Sinclair couldn't take it anymore, and so basically, any of us would, he would just try to find ways to help remedy his symptoms. And so the first person that he looked up, and I'm gonna remind you that throughout this process, he looked up many authors who actually specialized in natural medicine. The first person he looked up was Horace Fletcher, as you can see in this picture right here. And basically, what Fletcher suggested was that he chew his food slowly, because he believed that he would get maximum nutrients from it, and he would only eat as much as his system needed. Now, even though this actually looked good on paper, there were a couple of issues with the system, but Upton actually thanked it for setting him on the right track. And so basically, Fletcher's ideas were basically baby steps for Upton. And so even though he didn't stick with it for long, it was kind of like an early blueprint for what was to come, basically. So there were a couple of reasons for Upton's illness, and one of the major factors was that he ate a lot of processed foods. And so basically, after getting on Fletcher's method, he actually tried letting go of all those eating habits, but it was very hard for him to do. And so not only that, but he worried that he would either eat too much or he would eat too little, and the result was that he ended up losing 14 pounds. So he read Fletcher again, and he recommended removing the unchewable parts of the food. So by unchewable, that meant, for example, the skins of fruit. But however, remember when I told you that Fletcher's system had some flaws in it? Well, the problem was that there's nothing to stimulate the intestines, and because he was only eating the unchewable parts of the food, that meant that that also meant, because since he was getting rid of the unchewable parts of the food, that his body didn't really have anything to work with, and so because of that, waste remained in the body for many days. And so, as a result, he began having headaches, and his intestines started to slow. And so eventually, Upton moved from Fletcher to Metchnikoff and Sheridan. And according to them, with unassimilated food in the colon, bacteria starts to increase, and poisons begin to absorb into the system. And so eventually, Sinclair decided to have a bacteriological examination done on him, and the result was that when feeling well, he actually discovered that he had 6 billions to an ounce of intestinal contents. And so I'm going to let you guys take a guess on how many toxin-producing germs he had in his system for the headache. So for those of you that try guessing how many, he actually had 120 billion toxin-producing germs. Let me say that again, 120 billion toxin-producing germs. And so that's how many germs he had in order for his body to produce that headache. So Upton eventually went to a former Battle Creek Sanitarium, as you can see in this picture right here, to do a water cure. And even though it worked for a while, it actually left him where he started. So a week later, he actually got gripe again, and so he actually went to different health resorts, and he started living a hygienic life. And by history standards, a hygienic life would be no stress, no work, and no worry. And so he ended up exercising, he walked, he went boating, and he went swimming. However, his health actually got worse, was actually worse than before, and it ended up happening when he was working. And so the problem was that when he got sick, he began overeating in hopes that the food would be burnt up. However, some of it didn't, and it made him sick. And so he ended up giving up foods he once ate, but then it would only be to where he began eating other unhealthy foods. And so he ended up meeting this woman who once suffered from sciatica, acute rheumatism from intermittent peritonitis. And so what happened was that this woman decided not to eat for 8 days, and then the illness was gone. And so she actually ended up taking her son and his friend, and she ended up making them do a 12-day fast, and it actually ended up curing them of their nervous dyspepsia. And the same thing happened to her friend who had rheumatism, and she put her on a week's fast, and soon the rheumatism was gone. So that's when Upton began looking at books by Dr. Dewey, Dr. Hazard, and Mr. Carrington, who studied fasting. So one day, Mr. Sinclair actually got a sunstroke on the Gulf of Mexico coming home, and so he had to spend a week in the hospital at Key West after working, and he couldn't digest cornmeal and milk. Well, he couldn't digest cornmeal, mush, and milk. And so basically, this was basically the straw that broke the camel's back, because eventually that's when Upton decided to do a fast. And so on the very first day, he was very hungry, but then on the second day, he was a little bit hungry, but then it was gone. He also had a headache every 2 or 3 weeks. Although this lasted for the first day, it ended up disappearing, and it never returned. So for the second day, he actually ended up feeling weak and dizzy. The third and fourth days, however, on the third and fourth days, he had a clearness of mind. And then on the fifth day, he actually felt stronger, and because he felt stronger, he walked a lot, and he began writing again. Then on the first 4 days, he ended up losing 15 pounds, and he also noticed he had poor tissue health. And then on the 8th day, and then 8 days later, he lost 2 pounds. He also slept throughout his fast, and he would either get a massage or a cold shower. So he ended up breaking the fast after the 12th day with orange juice, since he would actually get pretty tired when walking. And so he did the orange juice for 2 days, and then he went on a milk diet recommended by Bernard McFadden. And so he ended up having the milk every hour the first day, every 3/4 of an hour the next day, and half an hour or 8 quarts a day. And so as a result, he gained 4.5 pounds in 1 day. And in the third day, he actually gained a total of 2 pounds in 24 days. And so with the milk diet, Mr. McFadden believed that it would actually help flush out the system more. And so that's why Sinclair did the milk diet. So he also experienced a clarity of mind, and he also had a desire for physical work. So after fasting, Sinclair began working out more, and he would enjoy doing it. He also started to notice that his muscles appeared out of his body, and he never really attempted a complete fast, but he would actually wait for the hunger to return. So originally he wanted to do a short fast. So that's when the hunger disappeared again, and he had no former issues. He also walked 4 miles every morning, and he did light gymnasium work, and he felt a chilliness. He lost 9 pounds in 8 days, and had orange juice and figs for a week longer, and made more weight. He also began eating foods that caused him issues, such as bananas, acid fruits, peanut butter, and the result was that he didn't have any issues. Sinclair also no longer had any headaches, and because of this, he actually went bareheaded in the rain and sat in the cold air, and he was actually immune to colds at this point. He also lived on a raw food diet for several months. So basically, overall, if he maintained a healthy lifestyle, he would be in good health. Sinclair soon found out that he actually didn't have enough energy to digest raw foods, and so that's when he began fasting again, and he also started the milk diet again. So, doing more research, he actually began he actually began studying more about fasting. And according to what he learned, he learned that when processed food and non-natural food is in the system, organs have a harder time getting rid of toxins. And so this results in organs getting clogged, as well as blood vessels. So this could result in headaches, rheumatism, arteriosclerosis, paralysis, apoplexy, Bright's disease, cirrhosis, and etc. So also you learned that with impaired blood, you can actually get colds, pneumonia, tuberculosis, or fevers. And so with this information, he actually ended up helping his wife and son because as I said before, besides him, his wife and his son did suffer a lot of health issues also. So with fasting, secretions cease, and with the assimilative system, which uses a lot of bodily energy when you're eating, it actually shuts down. And so at this point, the body begins cleaning itself. And for people, and so I don't know if this works for everybody, but for Upton, it actually helped. It actually helped him by taking an enema and a bath daily. He also drank plenty of fluid intake. He also had plenty of fluid intake or water. And so what happens is that when you're fasting, your tongue is going to become coated, and because of this, your breath and perspiration will be on the offense until leftover particles from the disease is gone. And I have more information about this towards the end of the video. And so it's going to talk about why the tongue has white coating on it. And so once the tongue clears, that's when hunger begins again. And so there's also a loss in weight. So a person could also lose weight, which will probably be like a pound a day. And so what happens was that the fat is used first, and then the muscular tissue. And so also according to his studies, starvation happens when the body is reduced to a skeleton and viscera, which is the internal organs in the main cavity, especially those in the abdomen. So as a matter of fact, Upton also found out that fasts of 40 and 50 days were common. He actually knew people that actually did them, and fasting was known to cure both emaciation and obesity. So after a complete fast, the body comes to its exact weight. So I guess the way this works is that for people who are stout, they won't regain weight, but for people who are underweight, they may gain a pound or more a day for a month. So Sinclair knew a man who actually fasted for 50 days, and so he did his fast, and then afterwards unfortunately, he started to indulge a little bit, and he indulged a little bit, and he ended up eating half a dozen figs, and so as a result, this caused intestinal abrasions, and he lost a lot of blood. And so drinking milk every day for half an hour, Upton realized that there was no chance to get hungry. However, the milk diet didn't always work for some. So what was said to do was that he had to break a fast with small quantities from fruit juices and meat broths for the first 2 or 3 days. And so Sinclair's wife got ill a lot, and as we have heard before, she got really sick a lot, and so she ended up having a severe appendicitis attack. And so unfortunately, the physician made a wrong diagnosis, and he kept her alive for 10 days with morphine. However, she was too low risk for operation, and they believed she would never recover. However, she actually started to fast, and she did it for 10 days. And so at the beginning of the fast, she suffered from stomach trouble, loss of weight, and neurasthenia. And however, after doing it for 10 days, her tongue cleared, and she lost 12 pounds in 17 days. She also ended up walking 4 hours every morning, and soon she felt better. There's also a man who suffered from asthma and dropsy and was on lots of medical drugs. He weighed about 200 pounds, and his legs were always leaking. His kidneys didn't work very well either, and so basically he went to the doctor, and basically the doctor told him that he was dying. And so basically this guy was basically this man thought he was going to die, but then his brother convinced him not to eat supper, and so that's when he started to fast for 7 days, and then he went on a 4-week-long light diet, and soon he began working on the farm again. So there were some other stories about people who fasted as well, and one story included a college student who suffered from appendicitis twice, and he ended up fasting for 5 days after the last attack, and 6 days later on, and as a result, he gained 30 pounds and became an athlete, and he ran 5 miles in 26 minutes and 15 seconds, and rode a wheel 500 miles in 7 days. And then we have the story of a young woman who suffered from a nervous breakdown and worry. And so not only that, but she also had issues with the bones of her spine since they began to soften, and her hip bones actually tilted upwards to about 3/4 of an inch. And so she fasted for 10 days and then 8 days, and then she took the milk diet for 6 weeks, and then eventually her health went back to normal. And so Sinclair actually came back from a railroad trip one day, and he actually had that severe gripe again, and so he fasted, and his illness went away in 2 days. He continued to fast for 12 days, and then on the 8th day, he was actually strong enough to shin himself 6 times in succession prior to fasting, and he was never able to do this more than once or twice. And so that's basically the story of how Upton Sinclair used fasting to cure his ailments. Okay, thank you guys so much for listening to this presentation, and I really hope you guys learned a lot and you guys enjoyed it. And I hope that everybody learned a little bit more about fasting today. And I hope you guys have a great day, and everybody just stay safe.